Presentation is here. Okay. Never. I can't see audience, no?
So there you can see. This one is
one person should be there, here on all the time. Should we start?
Yes, nice.
Good morning to all of you, all there on the other side. I'm DS Hani. I'm working in wireless communication. Okay, just to tell you about myself, I did my BTech long back, 1998 from Aurangabad. Then I did my MTech from IIT Roorkee, 2001. Then I did my PhD from JP University in year 2008. When I did my PhD, then my area was 3G that time. So since then, there are so many students working with me. Till now, I have finished 5 PhD students who have completed PhD with me. Most of them, they worked in the areas of wireless communication like OFDM, MIMO OFDM, wireless sensor networks, etc. And right now, there are 2 students who are still working with me. Many more are there in the queue. So today, my topic is going to be OFDM, Orthogonal Frequency Division Multiplexing. If you are aware of this, I know the audience is including engineering colleges and polytechnic colleges. So I have made my presentation. So in OFDM, if you are aware of this, it's the orthogonal frequency division multiplexing. So here today all 4G and beyond technologies mostly are having this OFDM concept. To start with, what is the meaning of OFDM? Since 3G, in fact up to 2G wireless communication, there was not a major problem of fading kind in any wireless communication. The main reason was in 2G and before that 1G, etc. all the data rates are below maybe 10 kbps or 15 kbps at the max. The things like GSM or IS-95, CDMA, they were very easy to work on. But as the requirement of user increases, day by day, number of people are too many, the number of applications are too many. So people move to 3G and beyond applications. Even up to 3G, it was not a very huge requirement of data rates. The upper limit was only up to 2 Mbps at that time. But right now we are working somewhere close to 4G and 5G. 4G is well implemented these days and 5G is about to be there in coming years. So OFDM is a technique which is used these days in all 4G method because the problem of fading is going to be avoided. One of the main technology which avoids fading is OFDM. So to start with here, the concept of OFDM is that we first break the data into small portion. Normally what happens, 4G speeds are around maybe 100 Mbps. And if you see 100 Mbps corresponding time, it is in terms of 10 nanoseconds. To start a bit of duration 10 nanoseconds is extremely difficult. The reason is that we have in wireless communication problems like fading, etc. So those fadings or multipath propagation or delay spread, they all are significant if we start sending bits at very high speed. So that's why it is not recommended to send these bits as it is. So what is done in OFDM, we convert this high data rate high speed data into many parallel number of streams which are having speed significantly less, like we were having 2G. So for example, if we have 10 Mbps data, if I convert that into 100 parallel streams, then each of the stream can be having data rate of 1 Mbps. So to handle 1 Mbps, it is comparatively easier compared to handling 100 Mbps. So that is the reason why we use OFDM, as I said. So as it is written here, we use a number of parallel orthogonal subcarriers to transmit data. Okay, just we'll explain it further in next slide. For example, if you see the bottom of the slide here, OFDM is a concept which comes under multi-carrier communication, and to differentiate multi-carrier communication with the single carrier communication, you can see this slide here. In the single carrier, like our traditional communication, AM, FM, or even 2G or some 3G methods, they are all single carrier communication techniques. So one carrier is used to send all the data. But on the other hand, in the multi-carrier communication, as I said earlier, we divide the coming data into many parallel streams. Each of the stream is having data rate very less. And to each of the stream, we give different carriers, either sine wave or cosine wave. And all the different streams, they modulate different carriers. And one of the property of these carriers is that they have to be orthogonal to each other. Yeah, the definition of orthogonality is going to be discussed subsequently. So by doing so, why we go for orthogonality here? Because the very basic reason of orthogonality is that if we send two signals which are orthogonal to each other, they are going to be treated independently at the receiver end. That is property with all orthogonal signals. So we can go for sinusoidal orthogonal signals or cosine orthogonal signals, or typically we can also consider complex exponential signals. Any of the three can be used for orthogonal signals. So that's why we in OFDM we use multi-carrier communication, because the problem of all high data is solved there. Now this slide gives you a bit of OFDM and why OFDM is different than FDM. We could have used FDM also. If you see FDM, what are its applications? FDM is also a technology where if we have n number of people, we need n number of bandwidths. But if you recall FDM, then there we need for n number of people, large set of bandwidth is required. And also in addition, between two successive bandwidths or signals, we should have guardband also. That's why OFDM, although it's a good to have, it also provides diversity, but it is not as efficient as OFDM, which is explained in the same slide. So in OFDM, if you can see here, it is possible that multiple carriers, they can overlap. This overlapping condition is only feasible as far as these subcarriers are orthogonal to each other. If you see the shapes of all the signals there, they are just kind of sync signals. And how we get sync here, it is just a Fourier transform of rectangular signal. Because whenever we send a data in digital communication or wireless communication, it is just a digital bit stream. So it's a digital bit stream, and if you see its Fourier transform, it is a sync signal. So only positive part of sync signal is shown here, and most of the OFDM, whenever we discuss it or we do the analysis on OFDM, mostly it is done on Fourier transform or F domain. That's why the signal also, the waveform here shown is also in the F domain. So if you compare these two waveforms, clearly we have edge for this OFDM. In the same specified spectrum we could place, you can see here six different bandwidth signals. But on the other hand, in FDM, we could only have 2 there. That is one of the benefit. It's not the only benefit. The other additional benefit, as I told you earlier, is that it also, one of the reasons to have OFDM is also that it reduces fading problem also, which is going to be discussed subsequently. Then how to pick the spacing between 2 subcarriers in time domain or F domain, that is going to be a part of our discussion right through this presentation. So now, last couple of slides, we conclude that why we use OFDM. It's one reason is that it is having higher spectral efficiency compared to FDM. Another is that it is having lower multipath propagation. So multipath propagation is always a problem for wireless communication, but it was not that significant up to 2G because we were having very less data rate. Less data rate, longer bit. So delay can be easily placed in initial part of the bit. That's why it was not a big issue in 2G and below that. So these are 2 major benefits of using OFDM. This slide also further tells you how OFDM is better than FDM. So 6 different signals have been shown which correspond to 6 different bits in FDM or 6 different users. But if you see OFDM, all the 6 waveforms have been placed almost in half the amount, half the bandwidth. So a lot of saving of bandwidth is there in OFDM. So it seems simple though, but one issue here is all the time there in OFDM that these subcarriers which have been shown here, they have to be perfectly aligned with respect to each other so that their orthogonality is maintained. If their orthogonality is not maintained, then even small change in subcarrier, it might lead to problem of ICI, which stands for intercarrier interference. Okay, so this is also associated slide to previous one, if you can see. So the first figure is showing multi-carrier. There 6 set of signals are shown. The next is single carrier technique. Third is OFDM. So if you see here, OFDM is not the only multi-carrier method, but it is better than all other 2 methods which have been shown. So let me tell you multi-carrier methods. Other multi-carrier methods are including MCCDMA also. MCCDMA stands for multi-carrier co-division multiple access. We also have that technology parallelly going with OFDM. That technology also has its own issues, but that can be used depending upon our receiver complexity or channel condition, etc. So ultimately, on this slide, it appears that OFDM comes out to be better than all other 2, multi-carrier as well as single carrier methods. Now, this slide also further explains OFDM versus multi-carrier. As I said, OFDM is not the only multi-carrier technique. Okay, so OFDM is one of the multi-carrier modulation method. And in OFDM, sub-carrier spectrum is overlapping. That's a benefit. Compared to FDMA, in FDMA, if we recall, bandpass filter separates each transmission, which we do not require here at least, as far as orthogonality is maintained. And in OFDM, each subcarrier is separated by DFT. Now this term which comes first time here, DFT, we'll see here, it is possible to implement OFDM with DFT, and finally, ultimately, instead of DFT, we can also go for FFT, discrete Fourier transform or fast Fourier transform. So discrete Fourier transform is for discrete signals. So normally we have signal in the time domain, continuous time domain, but if we sample the signal, it becomes discrete time. For all discrete time signals, we have DFT representation possible. And for DFTs, it is also given in the literature. The DFT can also be implemented using FFT, which is fast Fourier transform. Because we have these days FFT chips available, which can be used at the transmitter and receiver end. So one of the reasons why OFDM was so successful is that we have FFT, IFFT chips available, and they are quite cheap. They can be easily implemented in our mobile sets or any wireless devices. It do not add cost that much. That's why OFDM is so popular. So everywhere these days we use OFDM, we are bound to use FFT. Not Fourier transform, not DFT, but FFT only. Because it is very cost effective also, and it is approximately resembling DFT. Then OFDM can be baseband as well as passband. Okay. If it is baseband, we need not to have any modulation at all. But if it is passband, we should have modulation also, and two categories of modulation are normally used in OFDM. One is PSK, other is QAM, quadrature amplitude modulation. Now this slide shows a typical block diagram of OFDM system. It is a simplified one because there are a few components which are hidden right now. It's not research-oriented block diagram, but it is a simple block diagram. If you can see here, in the beginning, we have coming bits here. So many bits are coming, but as I told you earlier also, the data rate of these bits can be very large. So, for example, we can have data rate of 10 Mbps if you go for internet application instead of voice communication. So, this very high data rate has to be converted into low bit streams. That is always the concept of OFDM. So that's why in this figure, the very first block is serial to parallel converter. So the coming bit stream is divided into parallel bit streams, and parallel bit streams have significantly less number of significantly less speed compared to the coming data. Let's say, as I discussed earlier, if the coming data is at 100 Mbps, if I divide it into 100 parallel streams, each stream is having data rate now 1 Mbps. So it is 100 times lesser than what it is at the beginning of the transmission. So that is the very first block. Then this signal is typically known to be narrowband signal because the speed here is less than what is, but it is there at the input. All these narrowband signals are given to then quadrature amplitude modulation. Now why QAM here? If you see the whole block diagram here, okay, then it is only showing you the baseband OFDM. Nowhere in the figure you are given carrier here. Okay, that's why it is called as baseband OFDM system. So in QAM here, all the 100, as I said, just use the figure 100. All the 100 coming bit streams, they are given to QAM modulator. Again, the output of the QAM modulator is typically points. Okay, this is again a point of discussion that why we need points at the output of QAM encoder. If you see a block just adjacent to the QAM encoder, it's a IFFT block. IFFT it's just like inverse Fourier transform. Okay, inverse Fourier transform, its discretized version is inverse discrete Fourier transform. Then ultimately, practically, it is IFFT. And whenever we use IFFT, then IFFT needs discrete inputs and it produces discrete outputs. That's why the input of the IFFT block is always needing discrete input signals in F domain. But our signal in the beginning is only in the time domain. So just to convert from time into F domain, we need this QM encoder. If you recall QM encoder, if you are aware of it, it takes the bit stream, convert that into sinusoidal signals. And if you see the constellation diagram of QM modulator, then it just represents points. And those points are given to IFFT block. That's why I told in the beginning, this IFFT block needs point in the beginning. But all the points are in F domain or K domain, because in IFFT we use K domain. So these points are given to IFFT block. Then at the output we got signal kind of XN. There's all signal and system issues which are there discussed there. So it's not a big deal. It's very well known to people who are already having MB background, etc. So at the output of I-50 block, we have XN signal. Then comes next important component, which is unique to OFDM, which is a yellow block shown here, which is showing add cyclic prefix. Remember in OFDM, I told in the beginning also, it is good idea to work in F domain instead of time domain. So F domain, when we go in F domain, the analysis of the whole signal is comparatively easy. And what the cyclic prefix does here, so anyway, that is going to be discussed later, but just I am explaining in one line that cyclic prefix converts a linear convolution, which is normally there in all LTI systems, into cyclic convolution. And if we do that, its Fourier transformation implementation is very easy. So that is there. Then all these parallel streams are added once again. It is converted serially. Then there is D2A converter, and the signal is sent. So it is a basement of OFDM because there is no modulation as such. The QM, which is shown in the beginning, that QM is only for individual subcarrier. It's not for overall modulation. So corresponding to all this equipment at the receiver end, we have reverse equipment. If channel is fine, there is not any delay spread kind of problem, we are going to receive the signal accurately. So the next few slides will be explaining all these blocks one by one. So to start with OFDM carriers or OFDM subcarriers. Right now, right from the beginning, we keep on saying that we use so many carriers, so many subcarriers which are orthogonal to each other. This figure shows you 6 different waveforms. Okay, 6 different waveforms are there, and they are all are orthogonal to each other for one symbol period, capital T. Okay, so let's say to explain it further, let's say in the input of the transmitter, we have a signal whose data rate is 6T. Okay, we divide that data rate into 6 parallel streams. Each of the stream is having data rate capital T. So each of the stream has to be multiplied by one orthogonal carrier. So these are those orthogonal carriers, 6 orthogonal carriers, because we have 6 different streams there. In the figure we have shown only cosine waves. We would have taken it sine wave also, exponential, complex exponential also. So just randomly we picked here cosine wave. So if you see, the very first wave from the top is a cos wave with frequency, let's say f naught. Here f naught, once again, how to choose f naught now? The frequency of very first subcarrier. This f naught is equal to inverse of the symbol period, capital T. So I told you in the beginning that we divide 6T data which is coming at the input into 6 streams of T speed each. So that's why the symbol OFDM symbol is having duration capital T, and related to that symbol duration is our very first subcarrier f naught. So f naught is equal to 1 by capital T. So it is 1 by capital T, and all subsequent subcarriers has to be integral multiple of this 1 by T. So if I take 1 by T as f naught, then subsequent subcarriers has to be 2f0, 3f0, etc. Normally, the number of subcarriers chosen is always a power of 2. Okay, like 2 raised to power 6, which comes out to be 64. OFDM is a very common thing. We have 64 OFDM or 128 OFDM, or even 2 raised to power 10, which is 1024 OFDM representation. So as you keep on increasing the value of this 2 raised to power n factor, then the benefits are more and more, but obviously complexity also increases as you increase the size of the FFT or DFT. So the 6 signals all are orthogonal to each other. Now this slide gives you mathematically what is the meaning of orthogonality. Okay, it's for related to the previous slide here. There we were having 2 core signals, one with frequency, let's say mf0, other with the frequency, let's say nf0. So two cosine waves are orthogonal only if they satisfies this condition. When m is equal to n, then this integral for one period capital T, it gives you non-zero result. That answer comes out to be capital T by 2 here. But when m is not equal to n, then the answer has to be 0. So this orthogonality condition has to be maintained. Then only FFT IFFT works. Okay, because OFDM, as I told you, it's dependent upon subcarriers which are orthogonal. They are orthogonal only through this condition. Similarly, exponentials also you can have similar conditions. Sines also have similar condition. Okay, so this condition has to be met. One of the reasons why this condition sometimes do not meet is that because of ICI, which is a intercarrier interference. Let's say one of the device from transmitter or receiver is moving. One of the device is moving, then Doppler spread comes into the picture. Whenever there is a Doppler spread, then carrier frequency changes, and accordingly MF node and NF node, they are not orthogonal to each other. That's why sometimes we have intercarrier interference. So this problem, which is also called a synchronization problem, is must. The requirement is must in case of OFDM, which is not as significant in OFDM, FDM, because there we can have adjacent filters also. But here the orthogonality has to be maintained. To reduce ICI, the carriers has to be perfectly orthogonal to each other. Now this slide is further related to the previous slide. Okay, I told you that we have used only cosine waves, but we are not. Let's say if you go back to this particular diagram here, the second block was QAM, quadrature amplitude modulation. Whatever is coming at the input of this device, okay, it is given to two quadrature carriers, sine and cosine. Okay, then if it is given there, then we have two variables, one corresponding to cosine wave, other corresponding to sine wave. So instead of only having one variable an, we have two variables an and bn, where n stands for a particular symbol. Accordingly, you see here, overall signal at any of the stream at the input of the QAM block looks like this. Okay, an cos 2 pi n f naught minus bn sin 2 pi n f naught. Should I continue? Yes. So this if you solve this mathematically, it comes out to be under root an square plus bn square cos 2 pi n f naught plus phi n. So this is the expression which is there at the output of the QAM modulator before IFFT block. Okay, so the amplitude are dependent upon an and bn, and an and bn can take different values depending upon whether you go for 4 QAM or 8 QAM or 16 QAM. So if you go for 16 QAM, for example, an and bn has to be varied in such a fashion that we have 16 possible values. So that is anyway subsequently explained in one of the slides. Now this is how an and bn are calculated from the given signal as BT. Okay, signal at the input of the transmission. Okay. Now, previous to this, whatever we have shown, that was all happening at the transmitter end. Okay, so we are doing all this processing, and we started with the fact that if channel is fine, there is not too much fading, there is not too much delay spread, we should be able to demodulate the signal at the receiver end. This slide shows how the demodulation is done. If we assume that the signal which is sent at the transmitter end is SPT, this signal goes to the channel. If channel is fine, then the demodulation procedure is this one showing in this slide, the second line here. And you can clearly see here that the given signal, this formula actually just reflects that the coming signal SPT is multiplied first by cos signal, then it is integrated. And these two function, multiplication by cos signal, then integration, this is called as correlator. So at the receiver, we are just using correlators. Depending upon the number of streams we are having, if we have capital N number of streams there at the transmitter end, same set of correlators we require at the receiver ends. Okay, so as you can see in the integration, there are small n varies from 0 to n minus 1. There are capital N number of correlators there. So this way the decoding is easy. The decoding is easy only right now because we do not have any impact of multipath propagation or fading, which is going to be contradicted also in future slides, which I'll explain. So till now, whatever I've given, we should be aware of now. Overall OFDM, what it does, it converts a higher data stream into many lower data streams. Each of the stream individually is multiplied by carrier, which is orthogonal to other carriers. Why we do that? Because we want the data orthogonal. Then we combine all. These all are combined using a block serial to parallel converter. Then we get the output. Then that has to be given to IFT block. Okay. The output of IFT block is again kind of discrete or digital signal. Okay, if you pass this digital or discrete signal through D2A converter, you get baseband OFDM symbol, which is possible to transmit now. Okay, this was all the thing which are required for baseband OFDM. Now next is passband OFDM. Okay, everything else stays same for passband OFDM, but we have additional carrier now. Because if we want to use OFDM for multiple people, then each of the individual person has to be modulated on a different carrier. Okay, so ultimately the multiplexing is possible only if we use different carrier for different people. Okay, just to recall the things, when we did serial to parallel conversion, it was only for one user. A high data speed of one user is converted into many data streams of the same user, which is ultimately combined. So then given to IFT at the output of the IFT block, data is still corresponding to one user. But when you really want to have multiple access kind of thing, then you have to have multiple users. If you want to use multiple users, then we need modulation there. So that's why in passband, we need different carriers for different users. So if you see overall, there are two kinds of modulation happening. One is around the input only, where we use QM, but that QM is not the up conversion. That QM is only to facilitate all the 64 orthogonal subcarriers. It has different roles just to convert time domain signal to frequency domain signal so that IFT is possible. But the passband OFDM, which I am going to discuss right now, is that where we use one carrier, which is for all the streams. And because of this passband communication only, the problem which I told you earlier, ICI appears, because we send this up converted signal to the receiver end, and let's say if the receiver is moving or transmitter is moving, then one of the frequency might change, or the speed of user change, ultimately frequency changes, then ICI appears, orthogonality get disturbed, and there is a problem in reception in that case. So that is there in passband. Anyway, all practical conditions or practical scenarios, many of them are passband working, where we have two modulation, one QM at the beginning, other is up conversion. So we have mostly passband OFDM signal in wireless communication. Now comes the spectrum of OFDM signal. Okay, just to recall, if you have one bit rectangular pulse kind, its Fourier transform is sync signal. Okay, and if you modulate the same rects pulse on any sine wave for a specified period capital T, answer is again sync. But the center frequency of sync is FC now, carrier frequency, instead of F naught, instead of 0. Okay, so normal rect has Fourier transform sync centered at 0. So modulated rect has again a waveform sync but centered at frequency F, where F is 1 by T. T is a symbol duration. Okay, this figure shows you 5 different streams. They all have different carriers. Maybe if you consider the center frequency Fc plus Kf naught, then on the right side it becomes K plus 1, then it is K plus 2, on the left side K minus 1, etc. So five different waveforms are shown in F domain here. Right? In the time domain we added 5 signals, one under the other. When we goes into F domain, okay, on the time they all are same, but in the frequency they have different carriers. Fc here represent carrier frequency, F naught here represent 1 by T, where T is the OFDM symbol time, K is an integer, okay, which varies from 0 to capital N minus 1, where capital N are the total number of subcarriers. So typical OFDM spectrum looks like this. Okay, and if you see here, it has both positive components as well as negative components. But if you take mod of this, if you consider this whole signal as HF, then HF mod, everything is positive. And if you want to convert power, it is HF mod square kind. Then that also once again, it again is a kind of sync only. Appearance wise, it looks kind of sync only. And there is no negative component in that. So this is what is OFDM power spectrum. As I told you just now, everything is positive. It is still kind of HF only. If HF mod you take and HF mod square you take, shape hardly differs. So this is a spectrum of overall OFDM signal. Okay, it's NF domain. But one thing here has to be understood is that we have used IFT block in the beginning of transmission. Okay, and IFT always needs points at the input of IFT block. But here it's not points, it's a waveform. So this whole signal has to be kind of sampled. Instead of x j omega, we need signal kind of xk. Okay, x j omega is a Fourier transform. Xk is x j omega is a Fourier transform. Xk is discrete Fourier transform or fast Fourier transform. Both are, I am treating both as same because one is mathematical, other is practical. So the signal has to be converted into xk kind. That's why it has to be sampled. So later on, many of the slides I have shown just sampled version of this F domain signal. Okay, anyway, power at the output of IFT block is kind of this only. Okay, it's the sum of many sync square signals, right? This has to be received as it is at the receiver end if there is no problem in channel. But we'll see when fading occurs, this waveform which is sent, it is also disturbed. Now just to explain what we have learned till now, I'm just showing one example to you. Okay, in the example, there's a digital data is given here in the form of bit stream. Okay, I divided this bit stream into 4 parallel bit streams. Okay, so whatever is the data rate that at the input of the transmission, it is given to serial to parallel converter. There are 4 parallel bit streams. Speed of each is 1 by 4 of the speed of the input. So those streams are named as C1, C2, C3, C4. So the first step, serial to parallel conversion, is this. Then, depending upon this, okay, if you pick, let's say, the very first signal, C1. In C1 we have, in combination of C1, C2, C3, C4, we have total, if you see here, 24 bits here. Okay, 24 bits are there, and in under one head, C1, there are 6 bits. Out of those 6 bits, first 3 are 1, next 3 are -1. If you see this slide next now, we have accordingly plotted this signal. For C1, the first 3 bits were 1, 1, 1. Accordingly, there are three cycles of that. Okay, 1, 1, 1, then -1, -1, -1. Digital waveform is multiplied by orthogonal carrier. So, in this signal, the frequency or sub-carrier frequency of C1 is, let's say, F0. Now come to signal C2. If you just go back to the previous slide, C2 is this 1, 1, -1, 1, 1, -1. So here the green line reflects 1, 1, -1, 1, 1, -1. Then we again multiply this by a carrier. But the carrier we have used here is having double the frequency what was used for C1. So it is just a modulation in both the signals, but one with the carrier frequency, not carrier frequency, one with the subcarrier F0, other with the subcarrier 2F0. Similarly, is for C3, the carrier frequency is 3F0, for C4 it is 4F0. It is still orthogonal, all the 4 signal. Okay, it has been shown in F domain now, and all the signals, they are orthogonal to each other because we have chosen sinusoidal signals accordingly. Once again, it is a simplified block diagram explaining what I have given till now. So this figure shows you transmission of mth signal, mth OFDM signal. Okay, if you see at the input, there are total capital NC -1 number of bits coming in the mth signal, small m. Okay, so capital NC number of bits are there at the input, and we divide these capital NC number of bits into parallel NC number of bits. Then we multiplied each of the bit by carrier. Here, instead of showing sinusoidal carrier, we have used complex exponential carriers. So the very first bit from the top, A0M, okay, 0 represents 0th bit of mth symbol. It is multiplied by carrier frequency F0. Then next symbol is multiplied by carrier frequency F1, where F1 is equal to 2F0. Then A2 will be multiplied by F2, where F2 is equal to 2F0. This way, we have done this. Then they form finally all are added. So this middle portion is just kind of I50 block. Then it is transmitted through the channel. Okay, then once again at the receiver, if you reach there, which I had given earlier also, you have capital NC number of correlators, then integrator, then this is how the detection is possible. It is just a summary of what I have given till now. Now, I skip this because some of this I have already explained earlier also. It is telling you how the detection is possible at the receiver, and just to go back, this is the receiver. At the receiver, the very last signal at the end right side, A0M, A0, A1M kind of, it has two possibilities. The one possibility is that the output is AK, or other possibility is 0. Output is AK only whenever the coming signal is multiplied by the same subcarrier, and output is 0 if the coming signal is not multiplied by the same carrier, it is multiplied by different carrier. So this also seems to be explained in other slide. Now if you see overall, when you see the computer simulation, The typical OFDM spectrum looks like this. Okay, so it is just a combination of, it is just like this signal which I've shown you here. This signal was the ideal signal which should be there on the computer when the channel is perfect. There is no fading or multipath propagation problem, right? But practically there is some problem and your signal is like this. But it can be easily detected at the output because fading seems to be not that significant. Now comes the multipath channel. I'll tell you that what is the impact of multipath channel or delay spread on normal communication. The figure shows that there are 3 paths from transmitter to receiver. Okay, and transmitter is fixed here, base station, and the receiver is moving. The person is sitting in the car, person is moving. So right now, at any particular time, the person is receiving 3 different components. One is direct path or line of sight path with amplitude alpha naught and delay tau naught. Okay. Then similarly, first reflected path is through building with alpha 1, tau 1 parameter. Next, from one of the tree or from the forest with diffraction and scatter and things. Diffraction, having diffraction as well as scattering there, and the amplitude is alpha k and the delay is tau k. At the receiver end, if you see, there are 3 copies of the same signal, one after the other. So just, we have shown it in the next slide. If you see, the channel looks like this now. There is one component at tau 0. Okay, the left side figure where 3 vertical lines are shown. The channel is like this. There are three signals now, one coming at tau 0, other coming at tau 1, third coming at tau 2. Okay, if channel is that way, then our signal which is received at the receiver end, it appears to be there in the right side. We send sine wave, the dark black one is through line of sight, then the first dotted signal is through the building, then third path is through the forest. Okay, so you can see that second and third signal, third waveform enter into the next symbol. Now this is where the problem of multipath is significant. Okay, because second and third waveform enter into the second symbol and they are going to affect the beginning of the next symbol. If we do not do anything to reduce this, then this is going to be damaging our next signal, next symbol, OFDM symbol. So that's why the block which I gave in the beginning, cyclic prefix, has been used in all OFDM. So, okay, if there are more and more multipaths there, the number of reflections are more and more, and number of replicas at the receiver end are more and more accordingly. So one way to tackle this is, which has to be shown in the next slide, you will see. So what we do here, we just copy some part from the, if you see here, we add a gap called TCP. Okay, CP stands for cyclic prefix. So small gap has been added in the beginning of the symbol. And when the first symbol, the very first component of the first symbol reaches at the receiver, then the second part of CP starts again. Now what we get the benefit out of this, that is explained further. You see here, what is done here, we have picked the last, for example, 1/4 portion of the very first symbol and we pasted that in the beginning at the prefix end of the symbol, which is shown here in the violet color. So this is what is prefix, cyclic prefix, because the name, why this name appears this way, cyclic prefix, because whatever is the last 1/4, around 1/4 or 1/8 portion, depending upon how bad channel is, we pick some portion of the symbol from the back, put it in the beginning. Okay, So why we do that? Because all the reflections from various paths should be absorbed in that violet region. Okay, if we are able to do that, then our next symbol is not going to be disturbed because of our present symbol. Okay, that's why cyclic prefix is must. One of the other option which can be used, we need this small TCP kind of gap always. So instead of TCP, we can also have a blank period also, or some other which you call zero padding. Zero padding also is possible there, but gap has to be there. Why we maintain those gap, that gap? Because in this small gap, all the reflection has to be fit. Okay, depending upon the delay spread, we choose this particular gap. So this gap is always there. But as I told you earlier, we have two options. One is cyclic prefix. We can take some part from the back, paste in the beginning. Okay, that is cyclic prefix, or we can just maintain small gap in the beginning. Both are the possibility. But why we go for cyclic prefix in OFDM? Okay, the preferred choice compared to zero padding is cyclic prefix. Why it is so? Because when you use cyclic prefix, then the normal linear convolution of LTI system is converted into circular convolution. And the implementation of circular convolution in DFT is very easy compared to linear convolution. Because in OFDM, most of the analysis is done in F domain. So that is the reason why we use the cyclic prefix, because the implementation of FFT, FFT is easy, and F domain analysis is easy. Otherwise, zero padding also is one of the option. If you don't want to put cost of cyclic prefix, you can go for zero padding. Okay, but still, in all the OFDM applications, we will use cyclic prefix because it gives us benefit of linear to circular convolution. So the same is explained in this slide once again. If you see, if we have the very first rectangle from the bottom side is CP. Okay, you have useful symbol. We have taken some part of the first useful symbol. We have copied it and pasted in the beginning. Okay, so that we convert linear convolution to cyclic convolution. Then same is done in the second symbol also. Same is done in the third symbol also. But we have to make sure we do not take CP very large, because more is the width of cyclic prefix, more is the overhead which has to be sent along with the data to the receiver end. And if you send more overhead to the receiver, then transmission capacity decreases. So then transmission capacity decreases for that. So this is the reason why we should not have. So CP is always a compromise. If we use very small CP, then there might be a delay spread problem. If we use too much CP, then there might be capacity reduction problem. So there has to be a trade-off between the two. Now, till now, all previous slides, we have assumed that our channel was smooth. Channel was smooth because the delay spread was not too much. We have flat fading kind of problem. But moment we go for fading, which is frequency selective fading. Okay, we are not explaining here right now that how this frequency selective fading affect single carrier communication. That is a well-known thing. All single carrier communication are very much affected by fading, with frequency selective fading. Okay, but now in this figure we'll see that even if it is frequency selective fading, OFDM can somehow reduce this frequency selective fading, which is not possible to reduce in single carrier communication. As shown here, our red signal here, red line is showing the impulse response of the channel in F domain. And the blue signal is just the spectrum of OFDM signal. Okay, when the signal comes, it is passed through the channel. Okay, then
Now we continue, sir. Continue.
okay, then signal shown in red color is the impulse responsible channel in F domain. Okay, it is not flat like we have in the flat fading channel. So this variation in HF shows that it is a frequency selective channel. When this frequency selective channel is multiplied by the signal OFDM symbol spectrum, overall result appears to be there on the right side. If you see here, each of the individual subcarriers is not affected that much. Okay, so it is very easy to decode the signal at the receiver end. Okay, in single carrier communication, we have how we tackle this frequency selective fading. We are supposed to use equalizer of quite a big length, which is always complicated issue and costly issue. But in case of OFDM, because frequency selectivity is reduced significantly, we can use equalizer, but a 1-bit equalizer or 2-bit equalizer at the max is sufficient for OFDM. Or sometimes we do not require equalizer at all. So that's why the slide gives you the major benefit of OFDM. That OFDM is well suited for frequency selective channels. Okay, because individual bit stream after serial to parallel conversion is a narrowband signal compared to wideband signal at the beginning. And if you have a narrowband signal, then for them frequency selectivity is automatically very less compared to wideband signals. Okay, that's why in 2G systems or 2.5G system, fading was less because they were kind of narrowband signals. And the spectrum, whenever there is we have frequency selectivity, the spectrum also changes a bit. This is a typical computer simulation model which shows you the frequency selectivity in the spectrum of the signal. Now, let's now come to a very small addition to what we have learned till now. Okay, because the major issue is always channel, right? So channel estimation always is a problem in any wireless communication when we send high-speed data. So till now, all the subcarriers we have shown in FFT IFT block were using data subcarriers. All the subcarriers for data only. But practically, we know that the channel is sometimes time varying. Okay, because other transmitting modes.
Please continue, sir.
Sometimes when fading issue, channel estimation has to be done frequently, and whenever we do channel estimation, we need pilot symbols. Okay, that's why this slide tells you the pilot symbol has to be added in the normal data symbols. If you see here, figure on the left side. Okay, now as I told you earlier, it's not typical time domain. It's not typical Fourier transform waveform. It is a discretized version of Fourier transform where we have shown samples. All the vertical lines are corresponding to different subcarrier here on the left side. If you see here, the blue one, whose strength is shown to be more than the strength of black subcarriers, they all represent pilots. And the pilots are placed uniformly after some data subcarriers. And the role of these pilots is for channel estimation. How many pilots has to be added, that depends upon how complex the channel estimation problem is. If channel is highly time varying, then we need to add more and more number of pilot carriers. If channel is kind of flat only, we need not to have too many pilot carriers. Few set of pilot carriers are sufficient. Okay, so here along with the data subcarriers, pilot carriers are also added. So if in the IFFT block at the transmitter end, we have, let's say, 50 subcarriers. Then out of those 10 subcarriers can be used for pilots, remaining 40 for data. although it can never be 50 subcarriers in IFT, because one of the conditions for IFT FFT block is that the number of inputs and number of outputs has to be of the order of 2 raised to power n. Okay, one of the applications which I'll explain later is 802.11 LAN, where the number of subcarriers are 64. So there is a role of pilot carriers. So pilot carriers are inserted in between the data subcarriers, and the number of pilot carriers depends upon how bad the channel is. So this is one thing which has to be done in that block. Pilots are sent frequently, and number of pilots used is also a time varying factor. If channel is highly time varying, we use more pilot carriers. If channel is not time varying, we use less number of pilot carriers. Then there is one problem in OFDM, which is called peak to average power problem. Okay, if we use as I said you earlier, let's say now we use 100 subcarriers. If we use 100 subcarriers, then 100 parallel streams are there which has to be added before the IFT block. And when we add 100 subcarriers, then it might happen that each of the subcarrier, let's say it's a highly rare scenario though, it's a very rare scenario though, but it might be possible that all the bits, they're 1. And if we add all the bits which are 1, there are 100 such number of streams, overall amplitude is 100 volts per 100 units. And that's why the amplitude of this sum, when we add so many carriers, this is vary from 0, 1, 2 up to 100. Okay, so the treatment of the signal for 1 volt or 10 volt or 20 volt or 100 volt, it has to be same, which is a very difficult scenario. Normally in single carrier, our amplitude is not going beyond 5 volt or 6 volt or 10 volts. When we add 100 number of signals, then the overall amplitude is 100 times the voltage of the one signal. Okay, the voltage of, let's say the amplitude of one signal is A, the total amplitude can be 100A. So that's why the amplifiers which are used normally in single carrier communication, they fails for OFDM. Okay, so if we want to use OFDM smoothly, then we should have very good amplifier whose dynamic characteristics has to be very wide also. Okay, it should be amplifying 1 volt signal also, 10 volt signal also, 100 volt signal also, which is very rare. Very rare. So because it adds cost to this. Anyway, it's not recommended to have power amplifier or voltage amplifier or that bigger dynamic range. Okay, this slide typically tells that the fluctuation of the spectrum. Okay, when we add it is addition in, it's not spectrum actually, it is a OFDM symbol in time domain. When we have, it is only shown for 8 number of subcarriers. If all the subcarrier data is 1, you can see the top figure here, the amplitude typically might touch 8 volts, although it's rare though. So when it touches 8, and on the other hand, it also might touch sometimes -8. So the overall amplitude variation is -8 to +8, which is 16 volt. So that's why the requirement of power amplifier is having bigger. We should have power amplifier with bigger dynamic range. It is only for 8 subcarrier case, but if let's say we have subcarriers of kind of 1024, then so much dynamic range is required, which is not possible. Okay, so there's always a problem in this OFDM peak to average power problem. Peak power is significantly higher than average power. To avoid this problem, there are so many things which are proposed in the literature. Like one of the thing is just before that, we can see that the power amplifier should have such characteristics, very wide dynamic range. Okay, peak power can be very large, average power is just a moderate one. So that is a problem which is there in the power amplifier. Okay, this has to be avoided. There are different tools how we can avoid peak to average power problem. It is a well discussed problem since many years. There are few options there. We can go for clipping, etc. Whenever amplitude of, let's say, signal goes beyond 10 volts, we clip it. We keep it 10 volts only. Similarly, in the negative direction, when the signal goes beyond -10 in the negative direction, we clip there also. So clipping is one of the options, but it produces distortion. And also there are other alternatives, like we can have good coding techniques also. Forward correction codes can be used there. Scrambling techniques also can be used. So anyway, this peak to average power problem is there, but it can be sorted out. Another is important thing which is required or must in OFDM is OFDM synchronization. OFDM principle is possible only when we have orthogonal subcarriers. Okay, at the transmitter end there is no issue, but when we go to the receiver end, then receiver might be moving. If the receiver is moving, there is Doppler phenomena coming into picture. So overall carrier frequency might be changing. If carrier frequency might change, orthogonality of signals get disturbed. If orthogonality of signals get disturbed, then it's not a good reception. Then the reception occurs there. That's why synchronization has to be maintained. Okay. OFDM, although OFDM systems can handle frequency offsets of up to 2% of delta F, where delta F is inverse of symbol time. Okay. Sometimes 5 to 10% also can be tolerated, but if the Doppler spread is too much and person is sitting in a high speed train or transmitter receiver, both are moving, then Doppler effect is quite significant, and there is very large amount of change in frequency. So this totally disturb orthogonality and the reception becomes wrong in that. So that additional thing has to be maintained in OFDM, which is synchronization. Then choosing OFDM parameters. Okay, one of the important thing is subcarrier spacing. There are consequences that you can't choose subcarrier spacing too much, too high, or too small. Okay, if you choose subcarrier spacing too big, the problem is that we have very large cyclic prefix required there. Okay, and cyclic prefix. Large cyclic prefix means we have additional overhead. Transmission capacity reduces. So that is also not recommended. But if you go for very crowded subcarriers with very small spacing, okay, then it increases frequency sensitivity also. Then ICI may be more in that case, because more the spacing between the subcarriers, okay, then ICI can be handled easily. So anyway, there has to be compromise between spacing up subcarriers. Now, before moving to one of the application of OFDM, just now to summarize overall what is happening in OFDM, we split a channel into narrowband channels, which enable significant simplification of equalizer design. Okay, as I told you earlier, 1-bit equalizer is sufficient in OFDM compared to a large length equalizer in single carrier communication. Effective implementation possible by FFT. Okay, then these are a few benefits. There are few challenges also, like large peak to average power ratio, number 1. Number 2, synchronization problem is there. Number 3, ICI problem is there. So there are few issues also which are explored since many years. People are exploring this. Some solutions have been found. Okay. So just overall now, whatever I have discussed, I am giving you in this single figure here. The input data stream is coming. It is going to parallel streams, then added cyclic prefix, then power amplifier, then to channel, then ultimately to the receiver where correlator is there, and we are detecting it. Now we'll see the waveform on the same figure to make it better understandable. You see, when we see serial to parallel conversion, there are capital NC number of signals. Each of them before multiplication is a rect signal, and every rect signal is having a Fourier transform which is a sinc kind. And when all these are added, then we get such kind of waveform in F domain. If you see here, so many sinc signals have been combined, overlapped. Okay, and the spacing between two sinc waveforms is 1 by t, which is a symbol period, right? Then after that, cyclic prefix is added, then power amplifier, then channel. Channel shown here is frequency selective channel. Okay, so all the sinc waveforms have been multiplied by this frequency selective channel shown in red color. Okay, then output after the channel looks like this, right? So this is without any synchronization or proper channel estimation, because frequency selective is there. We can go for pilot carriers also. Once again, if you see left side, we have added now pilot symbols shown in the blue color, which I explained already. So pilot symbols have been added. The use of pilot symbol, the output at the cyclic prefix is appearing this one here. Now our output is as shown on the right side. It is well synchronized now. Because of this pilot facility, not only channel is well estimated, also synchronization problem has been solved. That's why we have this pilot carriers at the transmitter end. Now let's see one of the application which you are familiar with this already probably. It's a Wi-Fi or 802.11 LAN. 802.11 LAN, which is also called as Wi-Fi, it has so many varieties. Okay, one of the possible variety in that is having OFDM. There are two standards in Wi-Fi called 802.11a and 802.11g. They both use OFDM as a technique, right? 802.11a, for example, works in a band of 5.15 gigahertz to 5.35 gigahertz, as well as 5.725 to 5.825 gigahertz. 8 channels have been used in this. Every channel is having a total bandwidth of 20 megahertz, and we can have 12 channels possible to use in this band. Similarly, 802.11g is working in 2.4 gigahertz band. So we focus on the very first one, 802.11a only. Both use OFDM. Okay, as I told you here in this 5.15 to 5.35 gigahertz and 5.7, etc., you have 12 channels. Those channels are shown here. Okay, each of the channel is having bandwidth 20 megahertz. There is 30 megahertz spacing in the beginning of bands. Okay, 30 megahertz spacing at the end of the bands, and each of the band itself is having bandwidth 20 megahertz. So why this 20 megahertz has been chosen, I'll tell you just now in the subsequent slides. So in 802.11a LAN, in that case, these are the various parameters which are used here. We have total N, capital N is equal to 64 FFT size. I told you already that FFT size is always 2 raised to power n power. Here that small n is equal to 6, that's why 2 raised to power 6 is 64. 64 FFT size is there. Okay, sampling frequency is 20 megahertz. I told you that if you want to use FFT or IFFT block, then the signal at the input has to be sampled one. That sampling rate is 20 megahertz. Cyclic prefix is having capital L is equal to 16 samples there. So if you add both, it becomes 64 plus 16. Total 80 number of samples exist in one OFDM symbol. And the duration of these 64 samples is, you can see here, 3.2 microsecond, and the duration of cyclic prefix is 0.8 microsecond. So this way one OFDM symbol in 802.11 is having duration of 4 microseconds. Now these all parameters we are fitting in that I50 block. As I just told you, there are total 64 samples, right? And the sample has to be chosen in such a way that there has to be some provision for pilots also, for data also. Okay, as it is shown here, if the input side there are total 64 inputs starting from 0 to 63. So 0 is not used, the input 0 is not used. C1 to C26, there are total 26 number of subcarriers there. Then there are few nulls up to 38. Up to 38, that means there are 12 nulls from 26 to 38. Then C minus 26 to C minus 1, again there are 26 number of subcarriers are there. So out of total 64 subcarriers, we use 26 plus 26, 52 subcarriers. So out of 64, we use 52, that means 12 are not used, right? So that's why the small rectangular box on the left side, it is written as NF equal to 52, because out of 64, we use 52 carriers only. Okay. And also, there are 4 pilots used out of those 52 number of subcarriers. And the pilots are placed at, if you see at the bottom of the slide, pilots are placed at number -21 pin, number -7, +7, 21. There are 4 pilots used. You know that pilots are used for channel estimation. So it is just same thing which was there in the previous slide. Okay, in F domain or K domain. The total duration is 4 microsecond, 0.8 microsecond for cyclic prefix, where all the delay spread is covered. Total frame size is 4 microsecond. And this is the figure, which is once again, I am putting all the parameters of 80.802.11 into the actual OFDM block. Data comes, it is given to interleaver. Okay, you know what is the role of interleaver. Just data is intentionally randomized so that the burst errors are reduced. That's the role of interleaver in any wireless communication. So in 802.11a also we use interleavers. It's not the part of OFDM though. Okay, but 802.11a uses interleaver. Interleaver is used, then 40. Then these number of bits are 192. Then these are mapped with 16 QAM. So every group of 4 bits is mapped into a 1 QAM symbol. So that's why 192 bits has been converted into 192 by 4, which is 48 number of symbols. Those 48 number of symbols, we have 48 number of symbols which are given to IFD block, right? IFD block along with the 4 pilot symbols. Okay, it is shown here that 48 number of symbols are given directly from the data. 4 number of pilot symbols are added. Few nulls are there. Okay, then this is what is happening in the 802.11a LAN. So with that, this was our whole discussion of OFDM. Okay, just considering the audience, I haven't gone into typical research areas of this. Okay, people are working on this. Many research areas are there, and these are few applications which uses OFDM. Okay, asynchronous or asymmetrical digital subscriber lines, synchronous digital subscriber lines, etc. Wi-Fi, digital audio broadcast, digital video broadcast, WiMAX, Flash OFDM, ultra wideband is also one of the topic these days under research. Power line communication, these are various applications where OFDM is useful. You finished? Yes.
Query.
Yeah, if you are having any query, please you can ask.
Any query from the centers?
Any query from the center?
Thank you, sir.
No query, sir. Thank you very much.
Thank you, sir. Thank you. Welcome. Thanks a lot, all of you. I hope you understood some of it. Bye for now.
Sir, tea मंगवा रही है.
अच्छा.
Hello.
Hello, yes, sir. Hello, yes, sir.
Sir, I am from Government Polytechnic, Bid, Maharashtra.
Yes, sir.
Sir, there is a question about the session.
Yes, sir. Yes, sir. Please,
Yes, sir, please
sir
come.
is coming.
Yes, sir. बोलिए.
Good morning, sir.
Good morning.
Sir, in multi-channel, multipath channel frequency diversity, how cyclic prefix overcomes the need of complex equalizer?
How cyclic prefix overcome?
The need of complex equalizer.
Yeah. The thing is that normally what happens, equalizer, why we need equalizer when channel is too complicated, right?
Yeah.
And it is for wideband channels. But OFDM in the beginning only, it converted all the wideband signals into narrowband channels. It is just like a 2G channels now.
Yeah.
Yeah, whenever it is a very small data rate, then equalizers are hardly required at all. Ultimately, equalizer is required for wideband channels.
Yes.
Yeah, this is a simple reason why we don't require equalizers.
Okay, sir. Thank you.
Any other question, sir?
No, sir.
Or any other question from any other center? Fine, sir. Then.
Okay, thanks a lot. I'm here for 1 or 2 minutes more, that's it. Please ask if you have any query.
Okay, thank you, sir. Okay, all the centers, now we can have a tea break till 11:30.
Hello, sir.
Hello, yes, sir. Hello, yes, sir.
Sir, we have to send the list of participants.
All right, sir.
Please provide us your some email ID. On which email ID?
आपके पास है गरिमा मैम की? All right, sir. We'll text you or show you in a slide. We are going to display you, sir, Miss Ma'am Garima Ma'am's ID.
Easy है सर, अगर किसी की मेल आईडी से उसके दोगे ना.
हमने तो ऑफिस खोल दिया था आपने.
नहीं
कुछ और आया, कुछ लेटर. अच्छा ठीक है, मैं आ रहा हूँ थोड़ा 15 मिनट में ना।
ठीक है।
Hello.
Good morning, all the centers. So our next session is on mobile cloud computing by Aditya Bhardwaj. So he will deal with the mobile cloud computing topic and the research areas linked with that.
Thank you, ma'am. Good morning, all the centers. Myself, Aditya Bhardwaj, and I am regular research candidate over here. Today, in this session, we will discuss about mobile cloud computing, which is an emerging technology, and what are its real-time applications. Okay. Yes, I believe in one thing. Learning is not just restricted to listening. It is actively asking relevant question. So I request all the participants for session to be two-way interactive. If you face any query or any doubt, then you can pose me. Then we will have discussion session. So these are the agenda that we will discuss in today's session. Background for the session. After that, what is motivation for mobile cloud computing? Then what is mobile cloud computing and why we are going for mobile cloud computing? After that, we will go in some background of cloud computing. What are deployment models of cloud computing? That means how you can deploy your own cloud. After that, what is architecture of mobile cloud computing? How it works? And then various real-time application of cloud computing. After a conclusion from the today's session, then discussion. According to the latest report published by Internet and Mobile Application of India, total number of internet users in India 350 million. And out of these 350 million, 150 million internet users are using their internet by using mobile handset. So you can see number of users who are using internet rather than desk from your PC, they are preferring more on cell phone. So cell phone is increasing, gaining the advantage in the market, and it is also more preferable rather than your desktop computing. Because while on the move, you can do your all the web application services. You can surf the internet while on the move by using your cell phone technology. Even you can see business through mobile devices. 69% employees, they are preferring doing work by using mobile phone rather than going into the office. So on the home itself, you can do your all the office tasks. After that, people are preferring by using mobile cell phone for the internet in evening 73%, and for weekend purpose 51% employees or users are using cell phone technology or mobile phone for internet purpose. So just from this slide itself, you can get number of internet user, those who are using internet technology from cell phone, they are increasing. That means cell phone is gaining more advantage rather than your accessing the internet through your PC technology. So business is preferred over the PC for doing business. Like for sale purpose also, we are accessing Flipkart, eBay through cell phone itself. Even for banking purpose also, we are doing all the transaction through cell phone. So preference of user is shifting from your PC computing or desktop computing to cell phone computing for accessing the internet. From the research point of view, like normally we need MATLAB software. MATLAB software for what purpose? For image processing computing. So for image processing computing, as we all know, the, MATLAB is license-based software. So you need to purchase the license of MATLAB. And if you want to offer free software, then you can go for Scilab, which is open source software. And we all know that MATLAB is heavy software. Almost approximate dump of MATLAB is 3 GB. So what are the challenges for this? If you want to purchase MATLAB, then challenges faced by researcher or industry person. What may be the challenges? They need to get a good financial budget for purchasing expensive hardware and software, because MATLAB is costly software. Also, if you want to access MATLAB through your cell phone, that means you want to prefer cell phone for accessing your MATLAB. So what may be the limitation of your mobile device? In human life, mobile device like a smartphone, tablet, they are becoming, although they are becoming essential part of a dream of information at your fingertips, anywhere, anytime. But when compared to conventional information processing devices, these mobile devices are lacking resources. So solution for this, mobile cloud computing. That means if we compare with your cell phone, then something is there in your some limitation is there in your cell phone. Like there is limited battery lifetime. If you compute more heavy application, like we were talking about MATLAB, if you run MATLAB in your cell phone, then battery life will be degraded soon, and processing will be also slow for MATLAB image processing application. So there are some of the limitation of your cell phone that we cannot compare truly with your desktop PC. So in order to provide solution for this dilemma, there is a new concept of technology that is coming in the market, which is known as mobile cloud computing. So through mobile cloud computing, what you will do, you will use your cell phone just for getting the interface of your application, and all the computing will be done at cloud computing part. So now then a limitation, whatever limitation we check for the mobile computing, they will be overcome by mobile cloud computing. So mobile cloud computing is nothing but it refers to infrastructure where both data storage and data processing happens outside of the mobile device. So mobile cloud computing applications move the computing power and data storage away from the mobile devices and into a powerful and centralized computing platform located in cloud, which are then accessed over the wireless connection based on thin native client. Now, what is thin native client? Basically, thin native client is we are purchasing laptop or desktop. They are known as thick client. Thick client means they are having their own RAM and own processing CPU power. So if you purchase thin native client, then it will not be having its own RAM for booting the operating system and its own processing power. So it will be acting just like a device for giving your GUI interface. Just for GUI interface, you can use your thin native client. So mobile cloud computing, nothing but it is combination of your two technology, mobile computing and cloud computing. Now there may be one doubt in your mind, why do we need mobile cloud computing? Because mobile devices face many resources challenges like battery lifetime, storage, bandwidth. So the application needs cannot be fulfilled by the limited resource of smartphone. Although phone is smart, but it is not smart in that terms that you can run any heavy application on your cell phone. It will be limited in terms of your CPU processing power, CPU life cycle required, and the bandwidth required by your by the application and storage. Because a cell phone is limited in storage, you cannot run application which require 3 GB storage like MATLAB we talked earlier on your cell phone. Because for that you need heavy amount of RAM, and that can be fulfilled by only desktop computing, not by your mobile computing. So in order to overcome this these limitations of mobile computing, because we need mobile cloud computing, in which your cell phone will be acting just for interface purpose, and all the computing will be transferred at backend at cloud service provider. For example, high-end applications in the fields of image processing and natural language processing (NLP) are compute intensive, and thus the phone is scarce resources. On the other hand, cloud has unlimited resources in terms of storage, processing power, and etc. So all the computing will be done at cloud provider, and your cell phone will be acting just for GUI interface. So you can test the environment of mobile computing as well as cloud computing, both technology at one hand through your mobile cloud computing solution. Cloud computing offers advantages to users by allowing them to use software, platforms, and infrastructure cloud provider at low cost and elasticity in an on-demand fashion. That means you can access the services of cloud based on your own demand. And mobile cloud computing provides mobile users with data storage and processing services in clouds, obtaining the need to have powerful device configuration like CPU need, CPU speed, memory capacity, etc. as all the resources are intensive computing can be performed in the cloud. So whatever computing or processing or memory will be required by your application, that will be done at cloud provider, and output will be displayed at your cell phone. So these are the some of the solution or advantages of cloud computing for mobile computing, that combinedly integrating, we are saying that this solution provided by cloud computing or mobile computing combined is mobile cloud computing. Now there are a few reasons for using mobile cloud computing, like brain of your services in cloud. That means all the computing is done at cloud provider, and it is easier to share content and assets. After that, it is easier to maintain the data. After that, more immune to crash and deletion. Suppose if you are running your application on your local hand system, then there may be chances that it may crash, application may crash. So if you have not recovered the data, then data may go. Now, if you are using the cloud services, then benefit may be all these concerns of recovery of your data and recovery of your results that will go to cloud service provider. So you don't need to worry. You can just compute your application of the cloud provider, and results will be displayed through your cell phone. So you can run any heavy application on your cell phone by using cloud computing services. Now, before proceeding further for the mobile cloud computing, as we have already discussed, mobile cloud computing is solid integration of two technology, mobile computing and your cloud computing. So definitely we need to understand some few concept of cloud computing, what is cloud computing, and why we are using or preferring mobile cloud computing nowadays rather than your desktop computing. In cloud computing, the word cloud is used as a metaphor for the internet. Like usually what we do for the flowchart representation, in order to represent internet, we use cloud kind of symbol. That's why we are saying cloud is nothing but here application of internet for the computing purpose. So the phrase cloud computing is type of internet based computing where different services such as servers, storage and application are delivered to an organization, computers and devices through the internet. In short, cloud computing is nothing but you are accessing the services of some of the companies like cloud service, which we normally known as cloud service provider, for running your application, and you are paying whatever amount of resources utilized by your device application for the cloud service provider, whatever amount of storage, processing power, bandwidth utilized by your application. According to that, calculation will be done and you have to pay the money. So costs are based on consumption like storage, CPU cycles, and there is no need to buy and configure new equipment, because definitely all these concerns will go to cloud service provider and no software hardware maintenance required. Normally what happens if you are running any application, then definitely we need to purchase the license of that software, like we have talked about MATLAB. So in that case, what will happen? You need to concern about updation of your MATLAB, and you need to buy and configure MATLAB software. After you need to run the MATLAB on your desktop PC. And if you wish to run your MATLAB on your cell phone system, then there is a limitation for your mobile phone. Limitation in terms of your bandwidth and limitation in terms of your limited battery lifetime, computing power, and many more. So if you are accessing MATLAB on the cloud provider, that means you are getting the MATLAB as a service from any of the cloud service provider, then all these concerns will go to service provider. You will just use MATLAB software for running your application, and whatever amount of time your application has consumed in terms of parameter like bandwidth, after that storage, after that CPU cycles, you have to pay according to that. So all these hardware, software maintenance, updation, these concerns will go to cloud service provider itself. Now, why cloud computing? Now, why everybody is talking about cloud computing and many technology like big data, Internet of Things? Because in traditional software, what happens? You need to purchase the software, so you need to be concerned about license of the software. Now, what may be the hurdles once you purchase the software? If your software was used just for one application, and in future for another application, if you are not using your software, that means that is dead. So whatever amount you have spent for the purchasing of software license, that is not further utilized in future. So to overcome this limitation also, what you can do, you can use cloud computing services like pay as you go, no maintenance cost required. Normally, definitely what happens if we are going in some new city, we don't buy a new vehicle in that city. What we do? We hire some cab or taxi for our services. So based on our requirement, you just hire the services or application or computing power from another company that is known as cloud service provider for your purpose. Now there may be some confusion. What is the internet and cloud? Internet is basically medium for accessing your cloud services. So internet is a global network of billions of interconnected computers around the world, and it offers many resources and services such as World Wide Web and email. WWW World Wide Web offers users access to trillions of hyperlinked documents and focuses more towards offering all of the resources over the internet. So cloud computing is a direct result of this initiative, which offers many resources such as software, platforms, and infrastructure as services. So internet is used just a medium for accessing the services from cloud provider, and all the computing will be done at backend at cloud service provider. So you are just accessing the services. So without internet, there is no meaning and no sense of cloud computing, because definitely if you need to access services or from the remote cloud provider, you need internet service. So in order to use the concept of cloud computing, internet must be running at your own device. These are the components for cloud computing. Clients is there. Clients mean user, and data center is there. Data center is collection of servers where the application to which you subscribe is houses. So data center are basically heavy end server running at cloud service provider. So all the computing is done at data center part, and after that internet. So these are three components for cloud computing. Users must be there who is going to access the services of cloud. After that, cloud service provider must be there, and the services of cloud provider will be running at data center. After that, you need internet connectivity for accessing the cloud. You can access, there is no such requirement that you need high-end bandwidth for accessing the cloud. You can use the cloud services just by using a minimum 256 kbps speed. So just by this speed itself, you can get cloud services. So you don't need any good amount of bandwidth. Just from the minimum bandwidth itself, you can access all the cloud services. These are some of the essential characteristics or features of cloud computing. On-demand self-service. That means you can access the cloud services based on all your demand. Suppose you are running MATLAB on your you wish to run MATLAB on your mobile phone. Then for MATLAB you need computing power. Suppose you need some amount of RAM. So you can access that amount of RAM from the cloud provider, and we can access amount of computing or CPU cycles required for running your MATLAB from the cloud provider. So it is on-demand self-service. One more example, if you are running any application on your desktop, and immediately you need 2 terabyte of hard disk and 500 GB RAM, and for processor which is having i7 processor, your desktop cannot fulfill this requirement. So you can hire these services from cloud provider. So it is on-demand self-service. Ubiquitous, a second characteristic, ubiquitous network access through internet base. Through your login account from the cloud service provider, you can access the cloud services anywhere at any time, and from any device. Just you need internet connectivity. Another one characteristic is resource pooling achieved by multi-tenant application architecture. Resource pooling basically says that cloud service provider, they have designed their architecture in such a manner that over one data center itself, they are providing the multiple layering of services. So each user is isolated in each and every layer in order to prevent from interference. So there is security also, and their cloud service provider are efficiently utilizing the resources which are configured in their own hand. After a rapid elasticity and scalability, suppose if you are running any application or a project over your PC, and immediately you need high amount of bandwidth and computing power, or high amount of RAM for running your project, then on the cloud service provider you can easily scale that amount of RAM. If earlier if you are using 4 GB RAM, then you can easily scale from 4 GB to 10 GB, 10 GB to 20 GB, or directly from 4 GB to 1 TB RAM also. So it is easily scalable, and scalability features and flexibility also there if you are using cloud services. Last one characteristic, major services with pay per use. Like normally what happen, if you have hired any cab for your journey, then you have to pay according to that only. In the same fashion, in for cloud service provider also, whatever amount of resources you have consumed over the cloud for running your projects, you have to pay according to that only. Now there are some of the big titan in market which are known as cloud service provider, like Google is there, Amazon is there, after that Microsoft is there. So first one big titan of who develop or initiate cloud is Amazon. And cloud developed by Amazon, it is known as Amazon EC2, Elastic Compute Cloud. After that, Microsoft also came into the market, and cloud developed by your Microsoft, it is known as Microsoft Windows Azure. Then in order to gain advantage or in the market, then Google also came into picture, and cloud developed by Google, it is known as Google Cloud. So all the cloud service provider, they are offering the services based on your requirement. So you can access any services, any software over this cloud service provider, and you have to pay the amount according to the resources consumed by you on this cloud service provider. Also, if you are running your application, then normally in cloud what happens, your application will be replicated in by default 3 replica factor. So if you are running your application on Amazon cloud, and their data center in Sydney, then they are having a replica of client application over another data center also, like from one Sydney to Singapore and Singapore to USA. So that in case of any disaster, if there is a disaster in Sydney, then there may be recovery of application for the client. So later on, client cannot claim that there is no recovery of client application. So recovery also their fault tolerance is also there in cloud services, and each and every cloud service provider, they are offering these services. As compared to your desktop computing, cloud computing also more or less cheap also, because whatever amount of resources you need for your application, you have to pay according to that only, rather than purchasing the software for each and every application. Now in order to access, we will take illustration of Amazon cloud. In order to access the services of cloud, you need a few credentials. First one, you need a valid email ID. After that, you need your credit card information. After that, you need your cell phone for the authentication purpose. So what normally what do, you are having 2 flavors of services or 2 flavors of account subscription in each and every cloud service provider. One is free trial account, and another one is for business purpose. So just for free trial account also, you need to create 30 days trial by using your credit card, and $1 amount will be deducted from your credit card bank balance just for free trial also. Now in future, if you want to further extend your free trial, then just by request to cloud service provider, you can extend your free trial. So while accessing the cloud services, you need to be very precautious in terms that once you have deployed your application over the cloud, like we have talked about MATLAB, once you have deployed your MATLAB application over the cloud, and you have done all the tasks, then you need to terminate all the instances of your application. Otherwise, billing will be continued at the backend. So these are some of the precautions that need to be taken care by each and every client or user who is going to access cloud services. Otherwise, unnecessary amount will be deducted from your account, and there will not be any notification also until unless you configure alert mechanism on the cloud service provider. So here we are going to see how you can access Amazon Cloud for the services. So you need to create sign in, or you need to configure your subscription account. After that, suppose if you want to, if you need Red Hat services, or if you need a Linux platform, from you are using Windows on your desktop and you need Linux platform. So immediately on desktop you cannot install Linux platform. You need to format your window on your desktop PC, or you need to dual boot your PC. So rather than dual booting or formatting your PC, you can access these Linux platform, any services from a cloud provider. So here we are seeing how you can access a Linux platform from these are some of the screenshot from Amazon Cloud. So once you have signed up for Amazon account, log into Amazon Web Services and click on My Account. After that, navigate to Amazon EC2. EC2 is basically Elastic Compute Cloud Console. So it is the console where you can launch any amount of resources, any kind of resources for your own purpose. So you just click on after the launch instance and select AMI. Basically, Amazon has configured many, like you can see Microsoft Windows Server is there, Amazon Linux AMI is there, Social Linux is there, Ubuntu server is there, and CentOS will be there, Red Hat will be there, Fedora will be there. So you can access any server just within a few seconds of amount. Like we have for the purpose we have access here Ubuntu server 14.04, and so click here if you will further access these cloud services. After that, select instance type. Instance is basically whatever resources or you are going to access on the cloud service provider. These are known as instance. So if I am going to access Microsoft Windows Server, that will be known as instance. If I am going to access Fedora Linux, that will be known as instance. So choose instance type. There are many configuration of flavors of instance type within a Red Hat itself. What amount of computing or RAM of that Red Hat you require. Then configure number of instance, like as we mentioned, we are setting up, suppose we are setting up 1 or 2 node clusters, so please enter 2 as number of instance. Normally, if you are going to create a cluster of system, cluster of computer for your project or for your research purpose, then there will be hurdle of configuration at local hand. So you can just create cluster of system at cloud service provider easily, like we have seen here, just by inserting 2 number instance means how many systems you required. If I required 2 Ubuntu Linux platform at cloud provider, just by inserting 2 here, I will get 2 platform. If I will require my demand as a 10 Linux platform, then 10 Linux platform will be running for my purpose. Now billing will be according to whatever amount of resources or how many number of instance you have configured or you have used for running your application. So billing will be according to that. Now it is asking about add storage. Minimum volume size is like 8 GB, but we have there for one application we have used 30 GB for instance. So you can configure any amount of size. It is basically RAM that you have configured for running your application. It is showing an instance description, give your instance name and description. Like in big data, we talk about Hadoop. Hadoop tool for running your big data application. So define security group. security group for accessing this instance from your desktop. After that, it is launching the instance, review and launch instance. So these are some of the screenshots how you can access cloud services. Then instance is running. You can see here name of instance was Hadoop and instance type is t2.micro and availability zone is US. So data center location is in US and instance state is nowadays running and public DNS, public IP that is given by cloud service provider to your instance. So just within a few seconds amount of time itself, you can get any amount of number of Linux, any services from cloud service provider just by a click of system. There are advantages of cloud computing like lower computer cost is there. You don't need a high power and high price computer to run cloud computing web-based application. After that, since applications run in the cloud, not on the desktop PC, your desktop PC doesn't need the processing power or hard disk space demanded by traditional desktop software because your application is running on cloud service provider data center. So you need a device like you can access cloud services from your cell phone itself, from thin native client itself, from desktop computing, from desktop PC itself. So your client system is acting just as a device for accessing the GUI interface only. So all the computing will be done at your cloud. When you are using web-based applications, your PC can be less expensive with a smaller hard disk, less memory, more efficient processor. So these are some of the advantages of cloud if you are using cloud services. Another advantage is improved performance. So computer in cloud computing system boot and run faster because they have fewer programs and processes loading into memory. Definitely, if you are running any application on your systems and there may be many files or many software configured installed on your system. So if you are going for cloud, then booting of operating system will be done at fast because that Linux or that Windows platform will be dedicated to one client only. Reduce software cost. Instead of purchasing expensive software application, you can get most of what you need for free. So most cloud computing application today, such as Google, you are definitely normally you are using Google Doc for storing your files and data. So better than paying for similar commercial software, which alone may be justification for switching to cloud application. So instead of purchasing any high-end license-based software, if you are going for cloud services, then it is a more better solution because what happens today, if I am working on one application and I need MATLAB, so I will purchase MATLAB for my image processing application. Now later on, after 1 month, if this application is over and in future I am switching to another application like students are coming from mechanical department, so they need CAD software. So I need to purchase CAD software. Now in future, if I am working on another application, then I need to purchase another software. So unnecessary, I am purchasing the software just for one application itself. So there is no reach of that expensive software. Now if you are switching to cloud service provider, then based on your demand of your application, you can access any kind of software, any kind of services from cloud provider. So use that software and services based on your requirement. After that, pay according to whatever amount of resources you have used. So these are advantages of cloud provider. That's why now business and working of researcher also, they are going to be shift from your desktop computing to cloud computing. Instant software update is there. Normally what happens if we have purchased any software today, then in future we need to be concerned about updation of that software and hardware. Now rather than purchasing the software, if you are accessing the cloud services, then what will happen? Your software updation, maintenance of software, configuration of software, all these concern will go to cloud provider. So what happen? Cloud provider is already handling all these precaution and concerns for updation of each and every software. That means at the cloud provider, each and every software and hardware is updated according to latest version which is available in the market at today's time. So you don't need to be worried. User just can access the cloud services over the cloud provider. So when the application is web-based, update happen automatically in cloud provider and available the next time you log in into the cloud. So you will get the latest version of any software or hardware if you are going to access cloud services rather than your desktop services. When you access a web-based application, you get the latest version without needing to pay for or download and upgrade. So these are some of the advantages of cloud computing, that you don't need to be concerned about updation of software. You don't need to be concerned about purchasing of software, maintenance of software and hardware, configuration of software and hardware. All these facility will be provided automatically by cloud service provider. You just access the cloud services and run your application and pay according to whatever amount of resources you have used. Unlimited storage capacity is there in cloud provider. Like cloud computing offer virtually limited storage because they are having heavy end data center, and so whatever amount of storage you need for your project, you can access that amount of storage. So your computer current is 1 terabyte hard drive is small compared to 100 of petabyte available in the cloud. Normally we are talking about few 1 terabyte of hard disk on our local hand. And if you need any application which need few amount of terabyte for running purpose itself, so you need to extend the RAM and hard disk of your local system. So rather than going for that solution, if you are going for cloud services, then just in few amount of time you can access petabyte of RAM and hard disk available over the cloud. Increased data reliability is there. Unlike desktop computing, in which if hard disk crashes and destroy all your valuable data, computer caching in the cloud should not affect the storage of your data. As earlier in the few slides, we talk about replication factor, the replication concept. So in cloud, cloud provider are already taking the concern of backup of your data. If you are running your application, and you have choose data center location as Sydney, then part of your application will be stored at data center which is located in another country also, like USA, UK and many more. So if there is some disaster or there is some crash of your application in one of the data center, then easily cloud provider can recover your application data just in few amount of seconds from another data center which are located in another country. So there is no concern about crash of your data if you are using cloud services. So if your personal computer crashes, all your data is still out there in the cloud, is still accessible. And in a world where few individual desktop PC users backup their data on a regular basis, cloud computing is a data safe computing platform. As we all know, if there are some benefit and advantages of any computing technology or any technology, then there may be some limitation also. Limitation not in terms of any big hurdle, but a limitation in terms of definitely if you are accessing any services over the internet, then security is a major concern. Also, you require constant internet connection for accessing the cloud services. If there are frequent disconnection of your internet, then your application will be deployed partially over your device. So cloud computing is impossible if you cannot connect to the internet. Since you use the internet to connect to both your application documents, so if you don't have internet connection, you cannot access anything, even your own document. So it doesn't. So cloud computing doesn't work well with low speed connection. Low speed connection is minimum you require 256 kbps speed. So storage data might not be secure. With cloud computing, all your data is stored on the cloud. Question is how secure is the cloud? So security is also concern when you are going to access cloud services that during the network, is there any some attacker or hacker who is going to access your authorized data? So can unauthorized user gain access to your confidential data? So these are some of the flaws and concerns from user point of view before going to access cloud services. But practically speaking, from my own experience, if you are accessing cloud services, then security is already taken care by cloud service provider. So your data is secure at cloud service provider because your data is stored not in plain text form, but it is stored in many encrypted form. Also, what cloud providers are doing for giving the security of data to user, they are dividing the user data in different segment of amounts. So different segments of data is stored over different data center. While the driven of the application, now collectively it is computing and then result display. So security is not any big concern from a user point of view if they are going to access cloud services. Now, because of this session, you may be interested that how you can deploy, how you can develop your own cloud in your organization. For that, there are three flavors: private cloud deployment model, public cloud deployment model, and hybrid cloud deployment model. One by one, we will see what these technology are. Public cloud means services are delivered to the client via internet from a third-party service provider, which is cloud service provider. Like Amazon is there and Microsoft is there, Google is there. So these are three big titan of the cloud service provider. Now, apart from these big titan, Oracle is also coming with their own cloud. SP is also coming, and IBM has also gained the market for cloud provider. And cloud developed by this IBM is IBM Lumix. So if you are accessing cloud services of these cloud service provider, it is known as public cloud. Because cloud developed by these commercial organization, it is available to all the public users. So they need to just use these cloud services and pay according to that. So it is known as public cloud. Now there are concern or limitation of this public cloud is security is a major concern, because if you are going to access anything over internet, then security will come into place. Now if anybody is saying or interesting that they don't want to use cloud developed by another company and they are willing to develop their own cloud, so that is known as private cloud. So in private cloud, your organization can deploy or develop your own cloud. So these are the services managed and provided within the organization. Internally, you have developed the cloud for your own purpose. So there are less restriction on network bandwidth because internally you have developed the cloud. So you don't need to be concerned about bandwidth. Fewer security is there, fewer security exposure and other legal requirement compared to public cloud. Definitely, if you have developed cloud within the organization, the security is not a concern, because now you are not accessing anything from the remote place, and you don't need to be concerned about a legal requirement which have to be fulfilled between user and commercial organization before accessing the cloud services. Now you may be thinking how you can deploy your own private cloud within your organization. So there are some of the tools that are available, like OpenStack tool is there. Basically, OpenStack is an open source tool through which you can deploy your own cloud. So for deploying your own cloud, you need networking good amount of knowledge. After that, high amount of Dell data centers or Dell servers, Blade server that you need to purchase. After that, you need to create cluster of systems. Once you have created the cluster of system, and over this cluster of system, to provide the cloud environment, you need to deploy OpenStack, open source software. Just deployment of this software itself is not sufficient for deploying the cloud, but you need to be configure a lot OpenStack for creating the own cloud. Now, based upon the requirement of user, public cloud is there. Public cloud, if you are accessing the cloud services of cloud provider, because of some limitation of public cloud and security was a major concern, because definitely if you are going to access anything over internet, security will come into place. And you go for private cloud, how you can deploy private cloud, we have seen through OpenStack tool. After that, there are some application or situation that you need to taste the flavor of public cloud itself and private cloud itself. So if you are thinking that part of application that doesn't need security, you can deploy that thing on public cloud, and rest of the applications that are highly confidential for the within the organization, that you can deploy within private cloud. So that means if you are using the services or testing the environment of public as well as private cloud, that is known as hybrid cloud. So hybrid cloud is nothing but a combination of these services provided by private and public cloud, like ERP in private cloud and sales and email in public cloud. So data that doesn't need security, that you can deploy over public cloud, and data that is confidential for the organization that needs security, that you can use private cloud. So if you are using this combination of these integrated technology, that will be known as hybrid cloud. Now there are offloading technique concept in your mobile cloud computing, like if you are going to access MATLAB as a service over cloud service provider, that means MATLAB will not be running on your cell phone, but your cell phone will be used just for accessing the interface of MATLAB, and all the installation, configuration, processing of the application will be done at cloud provider. So you are just accessing the computing power and accessing the result of your project over your cell phone. So in that fashion, there are some offloading technique. There are two offloading technique. One is fully offloading, and second one is partial offloading. So offloading basically making use of cloud resources to perform the smartphone task. So this is done by offloading either application completely or partially to the cloud. In fully offloading technique, completely offloading technique, what will happen if you are going to access MATLAB as a service? Then total application will be deployed at cloud provider. But if you are going to use fully offloading, then what will happen? Because total application is deployed over cloud service provider, so you need to be concerned about amount of payment that you will pay to cloud service provider. Because if you are running total application of on the cloud, then amount of bandwidth and amount of network will be consumed more, so billing will be more. Now, rather than using a completely offloading technique, if you wish that you need to offload just sub part of your application. Suppose I am using MATLAB. MATLAB is running on cloud provider, and over that MATLAB I am using running my project image processing project. So if I am offloading just submodule of that image processing application, so computing will be done for that submodule only at cloud provider, and for the rest module of your project, computing will be done at your own local system, that means at your own local mobile handset. So billing will be reduced. You will be paying according to the resources or amount of network bandwidth consumed by that submodule itself only. You will not be paying for whole application. So billing will be down in partial offloading, and if you are using completely offloading, then billing will be more. So from billing point of view, these are completely and partially offloading technique. As we have talked, mobile cloud computing is combination of these two technology, mobile computing and cloud computing. So how you can access cloud computing or your cell phone? Here you have seen below mobile computing is there, about that cloud computing is there. So basic architecture of mobile computing will be definitely used. That means your cell phone will be communicating with BTS, and BTS will be communicating with BSC, and BSC will be communicating with NSC. After that, if you are using cloud services, then domain of cloud computing will be used. So mobile devices are connected to mobile network via BTS that establish and control the connection and functional interface between network and mobile device. After that, mobile user requests are transmitted to service provider mobile network services, and in cloud controller process the request to provide mobile user with corresponding cloud service provider. Whichever cloud service provider you are using, whether you are using Amazon cloud, whether you are using Microsoft cloud, or whether you are using Google cloud. So over your basic architecture of mobile communication, cloud computing services will be delivered. So in that fashion, you can use a mobile cloud computing service over your mobile computing. Oh, many of the cloud service provider, they are offering mobile cloud as a service. So if you if you later on, if you want to configure more regarding cloud computing service, how you can access it, then already built-in services there, like IBM is offering mobile cloud services, and for trial version also you can access, and for payment version also you can access. And cloud developed by your IBM companies, Bloomix Cloud. One more thing, for commercial purpose, for business purpose, if you want to filter the cloud service provider, then Amazon, Google, and Microsoft, they are basically, their cloud is developed basically for commercial purpose. And for education purpose, if you want to use the cloud provider, then better you go for IBM, because IBM has developed their cloud according to the requirement of education industry. So you can find out mobile cloud as a service over IBM in IBM platform. Amazon is also offering Amazon Mobile Cloud Services through Amazon AWS Mobile Hub. Application of mobile cloud computing. Cloud computing is used everywhere, like for mobile commerce and mobile learning, mobile healthcare, mobile gaming, and many more. In mobile commerce, what happens? It is also known as m-commerce. It is a business model for commerce using mobile devices. So you can do all your transaction or you can run all your projects over your cell phone, and computing will be done of your project at cloud provider. So your cell phone will be used just to access the interface of your result. So all the limitation that we discussed regarding your cell phone or mobile computing, that will be overcome by your cloud computing solution. And learning is there, mobile cloud learning, and in a traditional mobile based learning, what happens? Applications have limitation in terms of high cost of devices and network, low network transmission rate, and limited education resources. Definitely, if you are running any heavy software or any heavy amount of application or on your cell phone, then battery lifetime of your cell phone will be degraded soon, and it cannot fulfill all the requirement or computing power requirement of your application. So for that purpose, if you are switching computing or of your application over the cloud provider, then it will be a better solution, because cloud-based mobile learning application are introduced to solve this limitation. You will get updated version of software, and you will get a scalability of your application immediately. You can scale requirement amount of resources from 1 terabyte hard disk to 20 petabyte of hard disk within just a few click of amount. For example, utilizing cloud with large storage capacity and Powerful processing ability. Application provide learner with much richer services in terms of data, information size, faster processing speed, and longer battery lifetime. M gaming is there. Suppose if you are running any high amount of game which require high computing on your cell phone, then your cell phone cannot fulfill all the requirement of that game. So for that purpose, if you are using cloud services, so mgame is that means computing of your game will be done at cloud provider, and your cell phone will be used just to display output of your game result. So mobile game is potential market generating revenue for service provider, and Mgame can completely offload game engine requiring large computing resources to the server in cloud, and games only interact with the screen interface on their data. So your cell phone will be used just for providing the interface for your game result. Now there are advantages of mobile cloud computing, like extended battery lifetime is there as compared to your mobile computing. Because if you are integrating your cell phone, your mobile computing with cloud computing, then your cell phone battery lifetime will be improved, as application will not be computing at local center, but application will be computing at data center. So definitely, if you are not using any computing power for your cell phone, then battery lifetime will be improved. Improving data storage capacity and processing power, because you are using processing power of data center or server which are configured in cloud provider. So storage power is also improved, processing power is also improved. Improving reliability and availability. Your application will be reliable and it will be available at any time, anywhere. Just you need internet connectivity if you are accessing the mobile cloud services. Dynamic provisioning there, scalability, the remote application execution can have save energy significantly. So it will be sustainable computing also, because your application running over cloud data center, and it is not running at your own system. So already data center configured by cloud service provider, they are configured in such a manner so that they can fulfill the requirement of sustainable computing, and so that they can reduce amount of CO2 emitted by servers. Now, if some advantages are there, definitely there will be some limitation also there. So in mobile cloud computing, these are some of the issues. Not we cannot say these are limitations. These are just issues that need to be explored by researcher, industry person in future. Like security is a major concern. So one of the major concern with cloud computing is security of data. Often mobile user will provide sensitive information through network, and if not protected, can lead to major damages in the case of security breach. If you are accessing any services over the internet, then security will come into place. Definitely, if you are doing online transaction also, then also you need to be concerned about security. So security will be not from the cloud provider, but security will be during the transmission of data, during the networking communication, not from the data center point of view. Your data is secure at cloud data center, but there has to be some security concern that need to be explored in future when data is flowing in the internet. After that, you need connectivity. Internet connection is critical to mobile cloud computing, so you should make sure that you have good one before opting for these services. That means you need minimum amount of 256 kbps internet speed before accessing your cloud services over your mobile phone. These are some of the researchable issues that need to be explored in future, like operation level issues there and end user level issues there. In operational issues, it refers to underlying technology and matters such as method of offloading computation, cost benefit model that aid in taking the decision to offload or not. So how you can offload, how you can improve the existing offloading technique like partial offloading and completely offloading for further efficient mechanism. research is going in that fashion. In end user level issue, it refers to it related to issues that directly involve users, service level agreement, interoperability, and cost. There is a term SLA. SLA is basically agreement between client and cloud service provider who is going to provide the services to client. So in that agreement, some instruction or some statements will be there that at what amount of time you need to access your application and what amount of already configured bandwidth you will be using for your application. After that, service and application level issues, it basically relate to factor concerned with performance measurement of the system and quality of service of the system, like in what ways do mobile cloud computing system ensures availability, what are the fault tolerance mechanism employed to ensure smooth execution and uninterrupted services. So these are some of the researchable issues that need to be explored in future for mobile cloud computing. And as it is a new technology, so work is going on how to integrate the efficient offloading technique for mobile computing over the cloud computing. So we can conclude that cloud computing and mobile device will transform the software industry. So mobile cloud computing is the future. Now we will have a discussion session. Any query from any participant from remote center? Any of the query? Any query like how you can whatever we have discussed, how you can use cloud service provider services for your mobile computing purpose?
Yes, ma'am.
This is a query from Pipe.
Yes, ma'am.
So you have just presented a slide on researchable issues. So while you
Yes,
were
ma'am.
explaining, I too was having a thought that if you want to use cloud computing to provide education to those areas where there are no good schools or there is no updation of the technology. So as an electronics engineer, which of the researchable issues would be most significant for me?
Ma'am, you can offer that operation level issues for offloading technique. Basically, if you'll see good amount of journal like IEEE, elsewhere, Springer journal, then on offloading technique itself, research is going on. So you need to explore efficient offloading technique which will fulfill security concern also, and how load balancing will be performed while offloading your application, and what amount of sub module you need to be offload at cloud service provider so that cost may be minimized. So work is going on for the offloading technique, which is major big concern.
So does offloading connects only to those devices which are mobile? Like there was one point in that slide.
Yes, ma'am. Yes, ma'am.
So is it only connected with those end users which are mobile?
Yes, ma'am. In mobile, your cell phone, basically, definitely, if you are talking about mobile computing integration with cloud computing, then we are concerned with because in starting we are seeing now preference of user is shifting from desktop computing to mobile computing. So if preference is shifting, that means if they need to run any high amount of application which require high computing power, bandwidth, and network and RAM, then there are some flaws in your cell phone. So in order to overcome that flow, if you are switching for a cloud service provider, so your cell phone will be acting just for getting the interface, not for running the application. So all the computing will be done at data center part, and there will not be any concern from user point of view. So offloading technique is basically concerned with your cell phone itself.
Okay, sir. Thank you, sir.
Okay, welcome. Ma'am. Any other query from any participant from remote center?
Sir,
Good morning, sir.
Sir, good afternoon.
Yes, sir. Calling from Fight.
Yes, sir.
Sir, is there any protocol behind working in cloud computing, sir?
Any? Please pardon.
Protocol, sir.
Protocol. Okay, actually, like we have discussed about if you want to build your own cloud. So they are working on OpenStack cloud, OpenStack tool. OpenStack is basically a tool for developed by open source community people. So once you create cluster-based system, then just creating the cluster of system, it will not provide any kind of cloud environment. So in order to provide cloud environment over your cluster system, you need to configure OpenStack tool. So OpenStack tool, what it will do, basically it will create a virtual image of your physical system. Once it created virtual image, virtual machine of your physical system, then those virtual machine can be configured based on your different requirement for giving the cloud environment. So OpenStack is a tool that is used behind the cloud service provider.
Yes, sir. Because this is software-based technique, sir. In this, first we have to install application. So for the application, there should be some kind of protocol. I think so, sir.
Definitely, sir. For accessing cloud, like if you are going to access cloud from your cell phone itself, then if you are using Windows platform, then you need PuTTY software, PuTTY client software, and if you are accessing cloud services from Linux platform, then you need a SSH mechanism, secure shell mechanism for accessing the cloud services.
Sir,
So
if I am
protocol, yes, sir.
sir, if I am using Google Drive
Okay,
software, if I want to extend the limit of this drive storage capacity, then what is the process for this, sir?
yes, sir. Actually, if you are using Google Drive, then it will come into storage as a service from a cloud provider. Now, Google Drive is free of cost with limited amount of storage from Google point of view. Now, in future, if you want to extend, then you can use storage as a service from the Google Cloud.
Yes, sir.
Any other query? Okay, welcome, sir.
Yes, from any other center we have any question?
Excuse me, sir, there is one more query from Pipe.
Yes, ma'am.
So the query is that you have told us about the Amazon voice service.
Okay.
So can you have a brief illustration of how it is linked to the cloud?
Actually, we have discussed about during that screenshot session. We were discussing how you can access cloud through Amazon machine image. So in that we have access various Linux instances, like we access Ubuntu instance. So just by configuration or just by accessing cloud services, actually basically these are available as a services as a product. So if you are going for MATLAB as a service, or if you are going for Hadoop as a service, or if you are going for Scilab is basically open source. So if you are even if you are going for Scilab as a service, so these are available according to your requirement. What amount, which configuration of which subscription you are using over the cloud provider.
Okay, sir, thank you.
Okay, man. Note apart from yes, any other query?
Yes, any other question?
Any query from any of the participants from remote center? Okay, thank you. Thank you all for listening this session. Even in future, if you face any problem, then you can contact me through my email ID. Yes, ma'am.
Thank you all the centers. We will reassemble at 2:30 after the lunch.
Okay, thank you.
Thank you. Thank you, Aditya. हेलो, विष्णु जी बोल रहे हैं? हाँ, विष्णु जी गरिमा बोल रही हूँ। मैंने एक ना गेस्ट हाउस बुकिंग के लिए फॉर्म भेजा है, अभी भेजा है। All the centers, please call your participants. We are going to start the session within 5 minutes. Good afternoon, all the setters. We are going to start the last session of the day on VNet from Dr. Rakesh Kumar from CSC department. So I request all the setters, please call your participants.
Good afternoon, participants and local coordinators present at various remote centers. In this session, on the fourth day of this AICTE recognized short-term course on wireless and mobile communication, we will be discussing about one of the latest ad hoc network technology that is known as regular ad hoc network in the field of this wireless communication. We will be discussing how this technology is different from other technologies that we have covered till now in this STC, like sensor networks and WCDMA, and how it can be applied in various applications of day-to-day life. So we will be starting this session. But before this, I would like to just give a brief overview that you have already covered about the GSM technology. This is also one of the cellular or you can say wireless technology, but that is not a completely ad hoc network technology cellular, because in that case we have a stationary towers. I hope you have already covered about the 3G and 4G technologies in this case, and also WCDMA and security aspects of these wireless technologies yesterday in the afternoon session. So we'll be starting with this. So in this session, we'll be covering the wireless networks, why regular ad hoc network, and what are the classifications of regular ad hoc network, how it differs from the mobile ad hoc network, and what it is, why is it required, and how data aggregation and other challenges that are possible in this VANET. So starting with this, coming on to the just giving a brief introduction about this wireless communication. We say a network it is providing a wireless communication if there is no fixed, you can say fixed wires between this, and all the communication is going through with the help of only the air, through the air, and we are using the wireless communication between the nodes. But in case of wireless communication, nodes may be stationary or may be mobile. That is why we have classified these wireless networks into the three categories that can be fixed networks, mobile access networks, and ad hoc networks. In all these three categories, the communication is without wires, and we are using the antennas for the communication, and as well as the receiver and transmitter at both the sides. In case of fixed networks, like we have our labs in the classroom that are connected with the wireless LAN cards, all the machines are fixed. They are not mobile, but they are providing the fixed. They are fixed computers, but they are providing the wireless communication. In case of mobile access networks, like we are using the mobile phones. So in this case, some part is stationary and some part is mobile, like the mobile unit, or you can the cell phone that we are using is mobile, but the base stations, or you can say the towers that are used for the mobile access networks, those are stationary. So some portion of the network is stationary and some is mobile. And these mobile access networks can be further categorized into three parts that can be circuit switch, or you can say the circuit multiplexing that is used by the GSM. Likewise, you can also go with CDMA, that is also a kind of mobile access networks. And IEEE 802.11, that is the WLAN standards, are also the part of this mobile access networks. But we are more focused about this ad hoc networks, in which that is the completely infrastructure free networks, and everything is mobile, and it can be deployed in the any disaster kind of applications where it is very difficult to deploy the network with the help of wire communication. So these ad hoc networks are the kind of wireless networks in which nodes are mobile and they changes their topology on the fly. And it can be further, you can say, categorized in the case of wireless internets and wireless sensor networks. This wireless sensor network is also one of the major area in which the research is going on nowadays, and as well as for the last few years also, a lot of publication has been made in this area of sensor networks. So this is the example of this ad hoc networks as well as the cellular networks. In the left hand side, we can see we have the cellular networks, we have the base stations, those are stationary, and these mobile phones, those are these mobile unit, or you can say the handset, these are mobiles. So they can provide the communication with the help of towers. On the right hand side, we have this completely structure free network. That is, all the laptops, they have formed their own networks, and there is no predefined topology, as well as these nodes are mobile, so they are also changing their topology on the fly. So in this ad hoc networks, we have many challenges as compared to the fixed, or you can say the infrastructure based network, but it has advantages also that we will see in the future slides. These ad hoc networks can be further categorized into the many ways. One is the non-infrastructure that does not use any kind of infrastructure. It is also a kind of ad hoc network. Like just we have discussed, laptops, they are forming one network. There is no infrastructure used in this kind. You can also have a fixed and mobile nodes. We can also fix some nodes in our infrastructure free network. Like we have a network of suppose desktop machines as well as laptop machines. Those are connected with the help of wireless LAN card. That is also possible. So desktop machines are stationary and our mobile, or you can say laptops, are moving. And the special classes of ad hoc networks are, we all know, that regular ad hoc network, wireless mesh network, wireless sensor networks we have already discussed, Bluetooth scatternet also, that uses a piconet kind of networks using the Bluetooth technology. Nowadays it is not much popular because we are most focused about the Wi-Fi kind of things. So Bluetooth technology is slightly outdated, just like the IR, or you can say earlier we were using the different kind of technology before the Bluetooth. Now we are more focused about the Wi-Fi only. So we are more focused in this session about the vehicular ad hoc networks. So vehicular ad hoc network is a special case of mobile ad hoc network in which vehicles are basically the nodes and they form the network as the vehicles are moving from one location to any other location. There is a slight difference between the vehicular ad hoc network and mobile ad hoc network in a way that in case of mobile ad hoc network, the nodes are totally independent in case of topology. Nodes can go in any direction, but in case of vehicular ad hoc network, as we are talking about the vehicles, so the direction, or you can say the direction of movement of vehicles is predefined because vehicles can only go along the road. So as we have a layout of roads, accordingly the vehicles can move and accordingly the topology can change. So this is the example of vehicular ad hoc network. Shortly it is known as VANET. So we can see in this slide, we have vehicles moving from one place to any other place. We can also have the fixed roadside base station, similar to our mobile access technologies, just like we are using for cellular technology. In this VANET also we can have the mobile, we can say we have the roadside base station. Yes, is there any query from the remote center? So continuing about this, so we have, you can see in these slides, vehicles are moving and can have the vehicle to roadside communication. From vehicles to the fixed roadside base station, those are placed along the sides of the roads. We can also have the vehicle to vehicle communication for for the case where this is not feasible to deploy this roadside base station, we can communicate with the help of vehicle to vehicle. So we will see this how this network, this VANET is useful, because with the help of this, like we can see in this slide, there is an accident between the two vehicles. So with the help of VANET, we can send the message to all the vehicles which are coming behind, so that they can take the alternate or they can apply the braking depending upon the scenario. So with the help of in this, you can also have the coordinated driving as well as the platooning of the vehicles. That is also one of the application of this VANET. Centers, just wait for a moment.
मैम सर ये हाँ जी सर कंटिन्यू
Okay, so sorry for the interruption. So we are discussing this slide in which we have seen this vehicle to vehicle communication and vehicle to roadside communication. As you can see here, there is an accident. So with the help of VANET, we can send the messages to all the vehicles that are coming behind, so that they can take the alternative route, or they can apply the brakes beforehand, so that further accidents can be avoided. This is one of the use case of this VANET technology. So we can see here this regular network. These are the taxonomy in which we can say here we have the communication that can be vehicle to vehicle communication or vehicle to infrastructure. As we have discussed or seen in the previous slide, as roadside base stations are placed along the both sides of the roads, but it requires a lot of cost. So each and every country, we cannot afford so much of cost at the initial level. So if it is feasible to deploy the base station, then we can have the vehicle to infrastructure communication. If it is not feasible to deploy these towers, or you can say the base stations along the roadside, then we can have the vehicle to vehicle communication. And we can also have a combination of these two in case of this vehicular networks or simply the VANET. As we have already discussed, the network type, it can be categorized into the two ways. It can be ad hoc network or it can be the infrastructure based. In case of vehicle to infrastructure, we can say it is infrastructure based kind of network, but for vehicle to vehicle, it is a completely ad hoc network. The scope of this VANET can vary from local to the wide area network. For suppose a city scenario where the traffic is too much and the congestion is too high, it is a case of local. We are limited, suppose within a 2 km by 2 km area. So there also we can provide the services with the help of this VANET, and it is also feasible to have a very large area in such a kind of wide area. Suppose 500 km by 500 km area. Suppose vehicles are going from suppose one place to another place. You want to know what is the kind of weather over there. Is there any traffic jam over there? So that the other vehicles who are coming behind, they can take the alternative route, or they can change their planning for the traveling accordingly. The quality of service, that also varies from the application to application. As I have said to you, the applications of these vehicular networks also varies. Like we can have the emergency applications, like suppose there is accident, you can send the messages to all the vehicles who is coming behind. So it is a somewhat kind of real time, or you can say hard real time application, because if the message reaches late to the vehicles who are coming behind, then it is of no use. And there is another case of non-real-time application, like we are downloading the music while we are traveling in our car. So it is a kind of non-real-time application. Soft real-time, you can say when all the vehicles are moving in a platoons, like army vehicles, they are moving in a group. So they can also form a kind of cluster, or you can say kind of small network. So they can also communicate, in which if a message is delayed to some extent, then also it remains, its significance will be there, but it is advisable so that the messages can be reached in time. So it is a kind of, you can say, soft real-time application of this VANET. And applications like we can have the coordinated driving with the help of these VANET. You can provide the assistant to the driver, like emergency braking, automatic applying of brakes, like lane changing by the drivers, other kinds of signals that can be automatically sent to the vehicles, otherwise shown to the other vehicles accordingly. And it can also be used for the information dissemination. Suppose we want to communicate that there is a huge traffic jam or the very bad weather or a typhoon is going to come, so we can communicate, or you can say that disseminate this information to all the vehicles that are coming behind the forehand. So this is the taxonomy of vehicular communication system. This we have already covered. Like we have inter-vehicle communication, in which we are communicating between vehicle to vehicle, and RVC is basically the roadside vehicle communication, in which we are communicating from vehicle to the fixed base station. There is a third category, that is the hybrid vehicle communication, in which, as I said to you, because it is not always feasible to deploy the base stations at each and every location because it encounters cost. So we can have a combination of these two that forms the case of hybrid vehicle communication. This inter-vehicle communication can also be further categorized into the two parts. First is the single hop inter-vehicle communication, in which only two vehicles, those are in direct range of each other, because generally we say each vehicle is having a capability of suppose half kilometer. So they can, all the vehicles, those who are in the vicinity of this half kilometer, they can directly communicate without the help of any other vehicle, or you can say the roadside vehicle, roadside base station. But suppose those vehicles are much far away from each other and they are not in a direct range of each other, so they can also communicate by taking the help from the intermediate vehicles. So first the vehicle, suppose there are three vehicles A, B and C, but A is in the range of B and B is in the range of C, but A and C are quite far away. So A can send the message to B and further B can send the message to C that was basically meant for C and transmitted by the A. So this is a case of multi-hop inter-vehicle communication. And this roadside vehicle communication using the base stations can also be categorized into the two parts, like the sparse roadside vehicle communication and the ubiquitous roadside vehicle communication. In case of sparse roadside vehicle communication, these base stations are placed too much far away. The distance between two base stations is quite large. So it reduces the cost, and this is the case generally with respect to the highways, where the speed of vehicle is very high and traffic congestion is low. In case of ubiquitous roadside vehicle communication, we have more these fixed base stations placed along the road. Generally it is meant with respect to the city scenario where the number of vehicles are quite large. The same thing is written with IVC systems are completely infrastructure free. Only onboard units, sometimes are called in-vehicle equipment, are needed for the IVC. As I said to you, the vehicles are indirectly in range of each other. So this I have already discussed with you: single hop inter-vehicle communication and multi-hop inter-vehicle communication. The same thing is shown in this slide. So RVC systems assume that all communications take place between roadside infrastructure, including the RVUs and OVUs. So this I have already discussed, so I'm skipping this. Okay. So now coming on to the difference between the VANET and MANET. As I earlier said to you, that VANETs are a special case of mobile ad hoc networks. But still there are a lot of differences between the VANET and MANET. You can see the differences from this slide. Like in case of mobile ad hoc network, the mobility speed is very low. But in case of VANET, the mobility speed is very high as compared to the mobile ad hoc network. Because in case of MANET, generally the mobile unit is moving at a speed of pedestrian. But in case of VANET, the vehicles are moving up to the 200 kilometer, or you can say the 200 or 200 plus kilometers per hour. So accordingly, there is a change in the topology also. In case of mobile network, the topology changes slowly, but in case of VANET, the topology changes very fast and frequent because the speed of motion of vehicle is quite high. Likewise, the cost of production in case of VANET is low, but in case of VANET, it is very expensive. Node density is generally sparse. In case of VANET, nodes are the vehicles and they may be sparse or may be dense depending upon the scenario. In case of suppose city, the vehicles are more close to each other and it is dense. But in case of highways, the vehicles are quite far away from each other. So the vehicle density may be low. Transmission range, as I said to you, in case of mobile network, because the nodes are moving at a very slow speed, so up to 100 meters is sufficient. But in case of VANET, even 500 meter range, transmission range of the vehicles is very less because vehicles are moving fast. In the meanwhile, one vehicle come into the range of others, the topology changes, and in the meantime, the communication is not possible. Likewise, the bandwidth in case of VANET, it is up to several hundred kbps, but here the bandwidth required is very high. It is up to the several thousands kilobits per second. The lifetime of the nodes is depending upon the power source in case of VANET. There is no source of power in case of mobile network, and we are totally dependent upon the battery. But in case of VANET, it is completely different. There is no shortage of power in case of VANET because the battery is continuously being charged as the vehicle's engine is start and is continuously charging the battery. So there's no problem or there's no issue of power source. With respect to the computation capability, in case of VANET, even 8 to 16-bit CPU is sufficient. But for VANET, 32-bit CPU seems to be quite less. We need large processing power, high processing power CPU that is capable of processing the data at a faster rate because the topology changes very fast. We need to have communication very frequent. In the meanwhile, one vehicle comes into the range of another ones, just capture the data and take accordingly action. Addressing scheme in case of VANET is generally the unicast and attribution based addressing. But in case of VANET, the addressing, it may be unicast, it may be multicast, or it may be the location based. Suppose we want to send the information to all the vehicles who are coming behind to my vehicle, then it's basically the location based addressing. I want to send this information to all the vehicles, those geographically they are thus behind me. So this type of addressing may be required in this case also. So ability of multi-hop routing, that is true in case of both VANET and VANET, but it is available depending upon the scale of local network. In case of VANET, it is weakly available. Multi-hop routing, although it is available in case of VANET, but as I said to you, the vehicles are moving at a very high speed. Topology changes accordingly fast and frequently. So multi-hop routing is slightly difficult as compared to the VANET, although it is possible here. Reliability, you can say in case of VANET, the nodes, or you can say the communication between the nodes is not much reliable, or you can say the reliability level is up to the medium. But in case of VANET, the reliability required is very high because here we have even real-time applications, hard real-time applications also that are with respect to the passenger's life. So if he misses the message, or you can say the message drop is very high, then it can affect the passenger's life also in case of emergency kinds of application. With respect to the position acquisition, you can have the RSSI and ultrasonic triangulation in case of VANET. Here we have the facility of GPS, radar and other vision capability. Moving patterns of the node, as I said to you, in case of VANET, it is completely random. Randomly placed nodes are there, but in case of VANET, it is always regular, but regular with respect to the structure of the roads. Applications we have already discussed. There is no specific application of VANET Generally, it is internet-related. But in case of VANET, it is a specific application corresponding to the vehicle's communication only. So VANET is a special case of MANET, you can see. So MANETs are wireless multi-hop networks that lack infrastructure and are decentralized and self-organizing. IVC systems satisfies all these requirements and are therefore a special case of MANET. So inter-vehicle communication is basically a special case of MANET. But in case of roadside vehicle communication, we cannot say it is a case of MANET. Rather, it is somewhat a case of cellular kind of network. So there are several characteristics that differentiate IVCs from MANET. Some we have already discussed. Applications are different. In case of MANET, we have a general application. In case of MANET, we have specific applications. Addressing also different. In case of MANET, we have unicasting, but in case of VANET, we are having the unicasting as well as multicasting as well as location-based addressing. The rate of link change is also different in both the networks. In one, it is comparatively slow, but in case of VANET, it is high. Mobility model, that is also one of the key factors that differentiate MANET from the VANET. In case of MANET, as we have said, the vehicles, the nodes are moving at a pedestrian speed. So basics models that are being used for the last 2-3 decades, those are applicable for MANET, but they cannot be straight away deployed with respect to the VANET, because here the motion of vehicles is completely different in case of structure as well as the speed. Moreover, the energy efficiency we have also discussed, it is also the different. So applications we have already discussed. I am skipping this slide. Now coming on to this vehicular networks, we have discussed what is vehicular network, how it is a special kind of, you can say, the wireless network, or it is a special case of mobile ad hoc network. We have covered this. Now what is the need for this vehicular networks? We can see from this slide that every year these data are with respect to the US highways. Approximately 43 fatalities occur and more than 2.8 million injuries are there. And it costs around $230 billion to the society. This is with respect to the USA. If we take this data corresponding to over the globe, this figure will be quite large. So to combat such awful side effects of road accidents, or you can say the road traffic, European Union also, in case of European Union also, 40,000 people die yearly on the roads and more than 1.5 million injured. And apart from this, these are with respect to the fatalities. Traffic jams also generate a tremendous waste of time of the drivers as well as the fuel. So most of these problems can be solved with the help of vehicular networks. By providing the information to the driver or to the vehicle, there is a traffic jam ahead, you can take the alternate route. So traffic jams waste time as well as the fuel, and it cost to the country. Every year in US, driver lost a total of 3.5 billion hours and 5.7 billion gas that is wasted only with respect to the traffic congestion. If we go to the much populated country like China and our country, this figure is comparatively more high than this. So safety features and high-tech devices have become product differentiators that can combat this these side effects of these awful effects. You can see here accidents as well as the long queues of vehicles, those are stuck in the traffic jam. So in 1999, US FCC, that is the Federation Communication Commission, allocated a dedicated frequency band, that is the 5.85 gigahertz to 5.95 gigahertz band, to promote safe and efficient highways. and those are intended for vehicle to vehicle and vehicle to infrastructure communication. European Union's car-to-car consortium has also such kind of prototypes in year 2006. Radio standards for DSRC, that is the dedicated short-range communications, are also proposed, and now we have also dedicated 802.11p. 802.11 is basically for the wireless standards, and 802.11p is meant for this, for regular communication. So a vehicle, we are talking about this vehicle VANET and vehicular communication, but vehicle cannot communicate amongst themselves unless and until they are smart vehicles, or you can say the onboard units are attached with the vehicles. This onboard unit basically consists of few instruments, like we can say one is the central processing unit that implements the applications and communication protocols. A wireless transceiver is a transmitter receiver that transmits the data and can also receive the data from the neighboring vehicles or the roadside base station. A GPS, that is a global positioning system receiver, that provides the relative position, or you can say the relatively accurate position and time synchronization information with respect to the other vehicles in the vicinity. Appropriate sensors to measure the various parameters that have to be measured and eventually transmitted. An input-output interface that allows the human interaction with the system, because if my vehicle is if two vehicles are communicating among themselves but they are not able to transfer the same information to the human, then it is of no use. So there is a need for an interface that provides the interface between the humans and the machinery. So this is the modern vehicle. We can see here it has the forward radar as well as rear radar, human machine interface display in the form of a small screen, event data recorder. You can see the sensors, those are sensing the event that has been occurred. So suppose there is a pothole at a particular location, so the sensor will sense that there is a pothole here, and from GPS we take the location and stores this in the memory and then further communicate it to the other vehicles. Then this vehicle will have a computing platform and a GPS facility, as we have discussed. So this is a smart vehicle, or you can say the modern vehicle, which can be a part of your VANET. So these are some of the dedicated applications and services of VANET. Safety applications, those are, you can say, with respect to the hard real-time applications. Traffic management and monitoring, soft real-time, you can say, and comfort application, those are the non-real-time. So in case of safety applications, we can have the cooperative collision warning. In incident management, emergency video streaming. In case of traffic management, we can have the platooning of vehicles, vehicle tracking, if I want to track where is this particular vehicle, notification services. Comfort applications may be parking place management, distributing games or music or videos, and peer-to-peer applications like the games on the network. So how the vehicles can detect if there is a traffic jam here and I should sense this and send this information to all the vehicles. Those are going to come to, or consider going to reach at this particular location. This is possible with the help of a threshold value. If vehicles detect the congestion when number of vehicles are more than a particular threshold value, and this is not the only parameter on which this congestion is detected, and also the average speed of these vehicles is less than a particular threshold value, then it is assumed that there is a congestion. So these threshold values may be changed depending upon the depending on the hours of the day. Like we can say in the morning and evening during the office hours, or you can say the school hours, the roads are comparatively congested. So we cannot say that this is a case of congestion, because vehicles are moving slowly and number of vehicles are large. So we can change the threshold values depending upon the hour of the day. So It relays the congestion information accordingly. The one-hop communication as well as the multi-hop message forwarding is possible. Other vehicles choose the alternate routes. You can see here if one vehicle is going from suppose left side to right side, or you can see the from west to east. As soon as in between the vehicle detects there is a traffic congestion, it can take the alternate route. Moreover, we can have the deceleration warning information like that prevents the pileups when a vehicle decelerate rapidly. Suppose a vehicle applies emergency brake, so this message should be sent to all the vehicles who are coming behind, and they can apply the brakes of their vehicles automatically. Public safety applications are geared primarily toward avoiding accidents and loss of life of the occupants of vehicles. Collision warning systems have the potential to reduce the number of vehicle collisions in several scenarios. So, safety applications have obvious real-time constraints, as drivers have to be notified before the information is no longer useful. Either an MIVC or a URVC, that is a ubiquitous roadside vehicle communication, can be used for these applications. It is possible that depending on the communication range, an SIVC, that is the sparse inter-vehicle communication, may be sufficient for these applications. In terms of addressing the destinations in these applications will not be individual vehicles. As I said, we have in case of VANET, we have unicasting, multicasting, as well as the geographical area based addressing, but rather any relevant vehicle. So the zone of relevance, that is a new term that has been coined in case of VANET. Also, the target area is determined by the particular application. Some applications they may be limited to a small geographical area. Other applications they may be varied from large area. So traffic management congestion, we can have a traffic monitoring, traffic light scheduling, emergency vehicles, and all others. So traffic coordination assistance like platooning, we have already covered. Passing and lane change assistance, we have discussed this. Moving on to this IEEE 802.11p and IEEE 1609 standard family. These standards are basically meant for this VANET communication, or you can say the VANET vehicular networks. So in this we have 802.11p, 1609.4 lower layers, network layers, and upper layers. So that is the wireless access in vehicular environment, that is wave. So we can have a medium at the lower end, and upper layers are providing the communication with the help of IEEE 1609.1, 2, 3, and 4. So as we've already discussed that US Federal Communication Commission has allocated the 75 megahertz of DSRs, that is a dedicated short range communication for this VANET, ranging from the 5.85 to 5.925 gigahertz. And in this 75 megahertz spectrum, it is further categorized into the three parts as it is shown in the screen. 5.86 is for critical safety of life applications. So channels in this spectrum of 75 megahertz, it is further divided into the multiple channels, and these channels are also reserved for specific purposes. Some channels are reserved for hard real-time applications. So you can have the control channels, high power public safety channels also there. Generally, control channels have the higher priority as compared to the data channels. These are some of the existing approaches, challenges, and potential solutions that are proposed by the researchers in the past. Unique features of VANET we have already discussed. It's an unbounded network, high mobility, sparse and uneven distribution of vehicles. So for this, the models, those are already proposed, or you can say the kind of working models that are already proposed, they are somewhat different because like when we have the models proposed by the researchers, suppose some are meant for the uh, sparse vehicles distribution. So in the meanwhile, as soon as the vehicle move from one place to another place, the same model is not applicable. So we want a certain kind of model that is applicable for both sparse and uneven distribution of vehicles. Likewise, in some cases when there is a traffic jam, vehicles are moving at a very low speed, and in highways when there is no traffic, vehicles are moving very high speed. So there is a variation from suppose 10-20 kilometer per hour to a 200 kilometer per hour. So we can have such kind of protocols that can adapt such variation in the speed of vehicles. These are some of the unique characteristics of variant. You can have the predictable but highly dynamic topology. In case of Manet, the topology is not predictable, but it is also not much dynamic, and it also changes slowly. So as the vehicles are moving very fast, so there is a much more frequent network partition, or you can say the network disconnection. Mobility modeling and prediction is also very difficult. As I said to you, in case of pedestrian movement, the earlier mobility random waypoint mobility model is also suitable. But here those mobility models are not suitable. They need a dedicated mobility models on which you can predict the scenario that is going to be generated on the simulations. Because actual implementation of all these algorithms or protocols in the real environment, it costs a lot. So in case of simulators, we need a simulation strategy that totally incorporate, or you can say that totally signifies the real-time scenario. So here we have the geographical type of communication, apart from the unicasting and multicasting. Different communication environment, as I said to you, like in case of inter-vehicle communication and roadside vehicle communication, and that further can be sparse as well as the dense, depending upon the vehicle density in city or highway scenarios. We have here adequate storage as well as the energy, because as I said, the engine is always charging the battery of the vehicle. Hard delay constraint. So hard delay constraint is basically meant for the emergency messaging, or you can say the emergency applications. But these applications are basically the prime applications of VANET for which these networks were designed. Interaction with onboard sensor is also a unique characteristics of VANET. These are some of the big issues that those we can target in our further research. Like routing is a big challenge here, because nodes are moving at a very high speed. So there is a frequent network partition, or you can say frequent change in the topology of the network. So we need an algorithm that can adapt such scenarios easily. Likewise, quality of service is also a major concern here. This quality of service basically represents the qualitative and quantitative effect of the services that are provided to the user. So suppose there is a too much delay in the message that has been sent from one vehicle to other vehicle. In some cases, it is possible that the one time the message is reaching to the other vehicle in suppose 1 second, and at other time the same message between the same two vehicle, it may take a very long time. This is basically known as a jitter. So there are certain parameters on which we can analyze the quality of service of the network. So we always want to improve this quality of service, because this further increases the satisfaction level of the user. Likewise, we need to control the congestion. This is also one of the major challenges. The researchers who are going to work in this area are planning to work. You can target this. Like congestions we have discussed, it costs a lot in the form of time as well as the money to the society as well as to the individual. Security and privacy can also be dealt here, because the topology changes very fast. We need a strong algorithm, strong and less complex algorithm that can handle such scenarios. Scalability is also a big challenge here, because we want to adapt the same algorithm that is meant for suppose one scenario, like city scenario, and that can be adapted by the highway scenario also. We want to have a VANET that is capable of suppose communicating between suppose 200 kilometer by 200 kilometer area. Scalability, we want to adapt by the same network. The more and more number of nodes are vehicles are added. As I said, realistic mobility models are required. This data aggregation, or you can say data dissemination, this is also one of the big challenge, or you can say big issues. Because suppose there are multiple vehicles at a particular location, suppose there are 10-15 vehicles are there, and suddenly there is a vehicle crash, or you can say there is an accident. So at that particular time, all other vehicles will start sending the messages to the vehicles who are coming behind. So it will result in the congestion of packets over the network. Because the information is same, we don't want each and every vehicle to start sending the vehicle. So in this case, what we can do is we can aggregate the information. Like whenever we ask any student, what are your marks in suppose 10th standard or 12th standard, he will respond in a way, my marks are suppose 81%, 82%. We will not, we are not interested in letting know the individual marks of each subject. So he will tell us the average of 5 subjects. So likewise, we want to have the average, or you can say the aggregated information, not the individual information sent by each and every vehicle, because it will result in the channel contention as well as the congestion in the network. So after the aggregation, we need to transmit, or you can say the disseminate the same information to all the participants, or you can say all the users, or you can say all the passengers those are coming in the vehicles behind. So with respect to data disseminations, vehicular network need to handle the large amount of data, emergency messages, videos, and other kinds of. We have discussed the 3 categories of application, but these applications are totally different. Like emergency messages, they are with respect to hard real time, other one is non-real time, and soft real time. So you can see here, high mobility, dynamic topology, and receivers are a priori unknown. We do not know the receivers who are going to listen to this. As a result of that, maintaining the routing table with respect to the routing algorithm is very, very difficult here. So we need a mechanism in which routing table is dynamically updated with such a fast moving topology. Like this large scale and high density of nodes. So to accommodate large number of vehicles in a very, very large area, the scalability is also a big challenge. To deal with the low penetration ratio, when the number of vehicles are less, it will result in the network partition. So dealing with such scenario is also a big challenge, because if there is network partition, how we can transmit, or you can say the disseminate the information from one portion of the network to the other one. Each vehicle periodically detects the traffic conditions around it and forwards the information to the vehicles following, or you can say coming behind it. Redundant data is generated as a result of that. So multiple redundant copies of the same traffic status are clubbed together because they are consuming a lot of bandwidth. So this clubbing of information is done with the help of data aggregation, which is a very useful technique to reduce the data redundancy and improve the communication efficiency. This process of gathering and routing information through a multi-hop network and processing data at intermediate nodes, because we are gathering the information from all the nodes, nearby nodes, collecting the information and aggregating it, and then after that we are sending this information back to the network. So that is why we need an in-network aggregation. So communication is more expensive than the computation. We can say here that 70% of bandwidth consumption is due to the data transmission, and most of the time we have seen here this data that is transmitted, it carries the redundant information. That is why this in-network aggregation is required. Data transmission costs hundreds to thousands of times more than performing local computation on the same data. It reduces the number of data transmission by performing the local computation, eliminates the redundancy in data, and summarizes the data obtained by the network. Because we are not interested in all the messages that are generated by each and every node in the network, rather we are interested in the clubbed information that has been submitted by the this aggregation, this in-network aggregation can be further categorized into the two parts, that is the address-centric or the data-centric. In case of address-centric aggregation, we are more focused about the routing related, like how two messages or two reports can meet each other at the same time at the same node. But this is very, very difficult. So the data-centric part, that is the coding, calculation and compression of aggregatable data, like you can see here, the vehicle V1 that is transmitting the information, all the vehicles are moving here 30 miles per hour. Vehicle V2 is sending the information that 35 miles per hour vehicles are moving. So we are not interested in individual messages or individual report. We are interested in the clubbed one. As a result of this aggregation, we are having a 32.5 miles per hour as the aggregate. So finding the short routes between pairs of addressable end routes, you can see here to source 1 and source 2. We are sending the message, it is going to the sync node. So here we have the more traffic, but in this case, source 1 will try to send the message to the B, and there we club this information onto the report that has been transmitted by source 1 and source 2 at the node B only. So it results in less network traffic and redundant messages are avoided. So coming on to the mobility model, we have discussed about the various challenges in regular ad hoc network. What it is we have discussed. Now we need to implement all these strategies or routing strategies or other strategies in the real environment for the accurate result. And as I said earlier, the cost of implementation or just testing the new protocol or algorithm is very, very high. So we go for the simulation kind of work. So for simulation, we need the models that can simulate the real environment in the simulators. We have a lot of simulators available for this, or we can use a combination of some models like NS2. We can use either with a combination of Sumo and Move for WAN communication. Qualnet and other simulators are also available. So mobility model describes the pattern of movement of vehicles and how their location, velocity and acceleration change over the time. It is one of the key components in WAN simulations. But as I said to you, the real implementation of this WAN is comparatively costly. So it mainly affects the network throughput and connectivity. Mobility models can be further categorized into the three parts: node level mobility, information level mobility, and user level mobility. In case of node level mobility, vehicles are ad hoc in nature and may be moving. Flying unmanned aerial vehicles collecting the information as their carriers continuously change their location is the example of node level mobility. Whereas in case of information level mobility, that is the ILM, an event or source may occur in any part of the network at any instance of time. Like the pollution produced by a vehicle is moving along with it. It is somewhat a case of information level mobility because this pollution is moving along the vehicle. In case of user level mobility, users or destinations accessing the information directed by network are themselves moving, examining the traffic conditions on the way to the nearest fuel station. These are the examples of mobility levels. And these are some of the factors that affect the mobility pattern. Like what are the designs of road? Like if the roads are good, then vehicles can move at a higher speed. like the driver's behavior, what kind of behavior the drivers are having. Like if there is driver is driving a vehicle with lot of tensions in his or her mind, then the driving will be different. When the driver is cool and he is not in any kind of hurry, then the behavior will be different. What is the block size on which we are going to execute our algorithm, or you can say the protocol? So it is a 1 kilometer by 1 kilometer area or 50 kilometer by 50 kilometer area. This block size also affects the simulation, or you can say the factors. Traffic management system, like we are using the traffic lights, we are using the interconnection, connecting roads and other parameters in between or not. Attraction and repulsion points, like if there is any fuel station, if there is a big auditorium or big theater or mall that is attracting all the vehicles over there, so there may be some attraction and repulsion point. There may be some interaction points, like in the morning most of the vehicles are going towards the going towards the office, and in the evening most of the vehicles are going towards back to their home. Average speed of vehicles also changes, so that is also one of the factor that affects the mobility here. And time pattern of the day also affects, like in the morning during the office hours the traffic scenario is different. In the afternoon, in summers and winters, extreme summers and extreme winters, the traffic patterns is different. So these are some of the performance metrics that measures any mobility models. How much is the degree of spatial dependence, the extent of similarity in two velocities, in velocities of two vehicles, how much they are moving at the same speed. The other metric is the degree of temporal dependence, the extent of similarity in velocities of vehicles at two different time slots. Because in the morning, the vehicles are moving at a different speed. In the evening, vehicles are moving at a different speed. So relative speeds and average speed with respect to the other vehicles. Geographic restrictions, like degree of freedom of 2 points in a map and the various directions in which a vehicle can go after reaching that point. These are some of the performance metrics. This modeling label may be microscopic and macroscopic. In case of microscopic, that focuses on the movement of individual vehicles. We are not focused about the general movements of vehicle, like the vehicles are moving in a group like platoons, so we are not bothered about that. And we are focused on the vehicle behavior, or you can say the driver's behavior with respect to the others. But in case of macroscopic, it focuses on the motion constraints such as roads, streets, crossroads, and traffic lights. Also, the generation of vehicular traffic such as traffic density and initial vehicle distributions are defined in case of macroscopic table. So macroscopic is somewhat about the larger, you can say, the view, and microscopic is with respect to the individual's vehicle or individual driver's behavior. These are the classification of mobility models. Individual mobility, which is focused on the mobility movement of individual vehicle. Group mobility, auto-regressive, locking swapping, non-recurrent and knowledge-driven mobility. In case of individual mobility, mobility pattern of the individual mobile node, or you can say the vehicle, is considered based on speed, direction, transition length, and time between the two consecutive points and distribution of the mobile's position. Random waypoint mobility, that is one of the most popular mobility model, random waypoint mobility model that uses this concept. Group mobility, like communications are done among teams that coordinate their movements. Nodes always work together in a cooperative manner to accomplish a common goals. Multiple vehicles are moving in a group here, and they are trying to accomplish a common target. A function describes the group behavior, or the mobile nodes are somehow associated with a group leader or a target. Reference point group mobility, reference velocity group mobility are the examples of group mobility models. Autoregressive mobility, in which mobility patterns of individual nodes or a group of nodes together correlating the mobility states and considered that may consist of positions, velocity and acceleration at consecutive time instants. Repeated time instance के ऊपर हम इसको check करते हैं. The node location data is used to optimally predict the parameters. This autoregressive mobility may be individual mobility or maybe the group mobility. But these parameters like velocity, acceleration are measured as a consecutive time intervals or instants. In case of flocking swarming mobility, a coordinated movement, or you can say the coordinated task, is performed by dynamic mobile nodes over self-organized kind of network. Many interacting mobile agents with a common group objectives like flocking mobility and swarm group mobility are examples of these mobility models. There are a number of mobility models available for this. These are some of the popular mobility models. In non-recurrent mobility, all moving objects move in a totally unknown way and do not repeat the previous patterns. So each and every time a vehicle is moving, it is not going to repeat the previous movement pattern. Also, these moving objects can be vehicles of VANET that constantly change their topology, or the continuously moving data arises in a broad variety of applications like geographic information systems including weather forecast, air traffic control and telecommunications applications. The next category is the knowledge-driven mobility. It uses the knowledge of movement patterns of mobile nodes and can accommodate any arbitrary mobility patterns of mobile nodes, including the random walk, random waypoint, community-based mobility, and other well-known mobility models. It exploits the knowledge of the movement pattern of mobile nodes and provides complete freedom to mobile nodes. So in this case, we have the knowledge of the movement of the mobile nodes. Like we know, suppose a particular vehicle daily goes from A location to the B location. So we know we stores this information prior in the database for further action. These are some of the mobility models. Those are specifically designed for VANET. Like Manhattan mobility model, strict random waypoint model, also known as STRAW, Rice University model, traffic light model. These are the examples of mobility models that are meant only for the VANET and they are not applicable for the MANET. This is a comparative differences between these mobility models. You can have a look at this slide. So now moving on to the data aggregation, we need to basically reduce the number of redundant packets in the network so that channel contention can be reduced. So for this we can apply the aggregation, and after applying the aggregation we design our protocol, then we simulate those protocols on the simulators with the help of these mobility models. So we have discussed this data aggregation. Here we are focused about the knowledge-based structure-free data aggregation. So it improves the aggregation without any kind of structure, because in some kind of these wireless networks like sensor networks, structure-based aggregation is proposed, but their nodes are comparatively stationary. But in case of this VANET, nodes are comparatively mobile. So structure-based aggregation are not much suitable for this. So in this case of structure-free, These are suitable for dynamic event scenarios and no guarantee for aggregation for all packets. But here, there is no guarantee that all the packets are aggregated. Some packets may be aggregated and some may not be. So this is a diagram that shows the knowledge-based structure, this data aggregation system. In this, we provide the input as the information, then data is collected from all the nodes, and all the vehicles will have such kind of aggregation system in it. Then checking the relevancy between the data, whether the two data, or you can say the two reports or two messages that we have received, they are relevant enough to be clubbed or not. This is a big challenge to decide upon this. So whatever decision we take, whether this data is relevant or not, we will store the same onto the knowledge base. So this knowledge base will help in the future decisions, because if same kind of data comes from the same two vehicles, then we can first check the knowledge base whether such reports are already aggregated or not, and we can take the decisions accordingly. Then we will merge the data, or you can say the data aggregation, and then data dissemination is done, and we transmit, or you can say the disseminate the same information to all the nodes in the vicinity. So these are the components of this aggregation system, where in case of data collection, every vehicle frequently broadcasts the information in a frame consisting speed, x coordinate and y coordinate, and acceleration of the vehicle about itself and the vehicles in its vicinity. Now here we have taken x coordinate, y coordinate, acceleration and speed. 4 parameters are taken. You can take some more parameters. But as soon as the number of parameters are increases, the complexity of the system also increases. So upon receiving a frame broadcasted by other vehicle, each vehicle extracts the information from the frame and stores it in the database. So these are the components that checks the relevancy between the data. As soon as the information is stored in the database, each vehicle updates the information regarding its direct neighbor and the neighbor's neighbor. After that, each vehicle checks the similarity between the information, like whether they have come from the same geographical region or not. This relevancy information is then stored in the knowledge base and also passes to the decision component. Aggregation system has to make a decision whether multiple items of information are similar enough to be aggregated or not. So for structure-based data aggregation networks, this decision is quite simple. If the origins of the two data items belong to common cluster or a common subtree of an aggregation tree, then they can be aggregated. But in case of structure-free aggregation network, the decision is taken on the basis of the contents, or you can say the information that is stored in that particular report, and the fusible information is then tagged for later aggregation purposes. This knowledge base stores the information about the decision taken for fusion. This decision helps in deciding the further aggregation for other similar types of data items. Data structures like kiddie tree and graph may be used for maintenance of knowledge base. Data aggregation can be either syntactic or semantic. In case of syntactic aggregation, data gathered from multiple vehicles are either encoded or compressed in order to fit into the one frame. But in case of semantic aggregation, data from individual vehicle is first summarized in the basis of the actual meaning that particular report is carrying or message is carrying. So generally most of the researchers we are also focused on the semantics of the aggregation, and once it has been decided to aggregate two data items, a predefined method is required to join them. So after identifying fusible information and having combined the according information items, new information is available, and that is yet only known to the vehicle that performed the aggregation. So the vehicle therefore needs to spread the newly created information in the network, and this dissemination can be done either by flooding periodic beckoning, geo-broadcasting, or further following the tree structure towards the root. Now, to take a decision whether two data items are come from the same area, they carries the similar type of information, and accordingly the decision for fusion is taken. So such kinds of problems are very difficult to check. So this comes under the category of multi-criteria decision-making system, because here we have the multiple criteria, like whether two packets are come from the same area, whether they carries a similar kind of information. Like in this case, we have taken the 4 parameters: x coordinate, y coordinate, speed, and acceleration, deceleration. Other parameters may be taken. So multi-criteria are there to take the decision for whether the aggregation needs to be done or not. So this basically MCDM was proposed in the field of operation research, and later on it was incorporated in the field of vehicular ad hoc network. So here we take the yes, I'm speaking with 3 slides. So here we take the decisions on the basis of the parameters, and we assign the weights to each of these aggregation operators. So depending upon the weight factor, we multiply the weight factors with the aggregation x with w, and accordingly score is generated. On the basis of score, we check whether we need to do the aggregation or not. Like suppose we have given more weight to the location, whether two packets have come from the same location or not. In other application, we may change the weighting score to the different parameters. So we can apply these multiplicative or additive operators corresponding to the intersection and union functions. So the score is calculated on the basis of goal and constraint, or you can say the application where we are going to use this system. So the vehicular data that will be used to compare any two vehicles for data aggregation will consist of different components like x coordinate, y coordinate. This I have already covered. Graph and 3D tree structures may be used for this wireless, for this VANET vehicular, for the maintenance of this knowledge base in vehicular communication. However, this 3D tree is most appropriate as it can represent data with multiple components or data of multi-dimensional nature with less complexity. The complexity of this 3D tree is less as compared to the graph data structure. So two data sets of vehicles are represented as a disconnected graph, so that each vehicle corresponds to the vertex in the graph. So we assign the weighted edges, weighted score to each edge, whether the same vehicle represents the same location in the other graph or not. If there is any difference between them, that is noted with the help of small edges, small weights. So the weight for each edge will be calculated as described in the multi-criteria decision-making system. So minimum the edge weight, it is more suitable for our system. So in case of KD tree, it is basically a binary tree that is especially useful in representing data that has a multiple dimension. Like we have taken 4 parameters, which is basically 4-dimensional tree. As soon as the number of dimensions are increased, or number of parameters are increased, we can have the more number of dimensions in case of KD tree. So this KD tree basically has a good searching capability as compared to the graphs. That is why it is less complex as compared to the other one. So this KD tree has a complexity of basically O log n in case of single point balanced insertion, and building the static KD tree is basically n log n square complexity. So this is the KD tree structure shown here. You can have this. First, like we have 3 parameters here: x, y, and speed, 10, 29, and 25. So all the left hand side nodes, they will have the x coordinate less than that. Like you can see at the top, we have the value of x as a 10. In the left hand side, the node will are having the value of 7, 2, and 5. All the values are less than the top value, that is 10, and all the right hand side nodes will have the value more than 10. That is 11, 13, and 12. So accordingly, this KD tree will work, and it is used for this knowledge base maintenance. So this is the KD tree structure that is represented on the multiple dimensions. So just I will discuss one more problem here. Like there is also a big problem that is discussed in the case of this VANET, where more number of vehicles are there in a particular area, or you can say the city scenario. So there, this problem of congestion is very high. More number of packets are circulated. For this, the researchers has already proposed an algorithm, but still when this node density is very high, then still more and more number of vehicles are sending the same information in the vicinity. Like this gray area in the this circle, we can see there are still many number of vehicles. Those are sharing the common location. Still, it will result in the congestion. So for that, we have used one more parameters, that is the node density. So if the x, we start just one random number x between 0 and 1, and if x is less than 1 upon density of the available vehicles, then the timer is started. If not, then the frame will not be rebroadcast this particular packet. Generally, as soon as a packet is received by a node, it will resend the packet. But as I said to you, when the node density is very large, more and more number of vehicles are sending the same packet. So that can be reduced by using the one more parameters, that is the density of the vehicles in the vicinity. And accordingly, we take the action. Just when we have shortage of time, we are skipping 1-2 slides here. So decision taken by the vehicle is stored in its own local knowledge base, and after a regular interval, each vehicle also communicates the information in terms of decision taken by itself to all its neighbors for future decisions. So this knowledge base will store the information about the decisions that has been taken by this particular vehicle, and all other vehicles, those have taken the decision on two particular reports, those are same or similar with respect to these reports. So it will be communicated to other vehicles also. Now in the end, I would like to conclude that this VANET technology is one of the latest technology that is used in the area of VANET, and you can say the smart communication. The people who are trying to work in the area of VANET, they are encouraged to do the research in this. I have given you direction in the big issues or challenges, those are available in VANET, and these are some of the projects and organizations, those are well-known organizations who are working on the VANET. So if you have any kind of interest in doing research in this VANET, just go to the websites of these organizations like Car-to-Car Consortium, CarTalk 2000. Although these are some slightly older projects, these are still renowned, and if a person is going to start the research, they should focus on these also. Network on Wheels project, FleetNet projects. These are some of the journals in the area of VANET. These are some of the reputed conferences in the area of VANET: Mobicon, Infocom, Globecom, Mobihawk also. And these are the references that we have used for this presentation. So thank you, participants, those are present at the various remote centers. If you have any query, you are most welcome.
Yes, if any of the centers have any question, they can ask right now.
Is there any query from any of the participants present at various remote centers?
Oh, yes, sir.
हेलो
हाँ जी सर बोलिए।
हेलो
Yes, sir, you are audible. Please speak.
हेलो
हेलो
हाँ जी सर आप ऑडिबल है, प्लीज पूछिए अपना क्वेश्चन। यस सर यू आर ऑडिबल, पूछिए अपना क्वेश्चन। हेलो हाँ जी सर पूछिए, आप ऑडिबल है।
जी बोलिए सर।
हेलो
Yes,
हाँ
sir.
जी सर हम सुन पा रहे हैं आपको, पूछिए क्वेश्चन अपना।
गुड आफ्टरनून सर।
Good afternoon.
हेलो
जी सर, आप पूछ सकते हैं अपना क्वेश्चन। You can ask.
सर, आई एम कॉलिंग फ्रॉम वाइट।
यस सर।
Yes, sir. Please.
Sir, on this technique, can we use LTE, sir?
On this technique, we can use.
LTE, sir, long-term evolution, sir.
Basically, sir, LTE networks are 4G kind of networks. As we have already discussed, कि this cellular technology is somewhat different from this VANET. This VANET corresponds to basically the 802.11p standard, and this cellular technologies like LTE technologies, they uses this CDMA and GSM kind of technologies. So for the developing countries, for the start, we can use the base stations, or you can say the towers. Those are deployed for the cellular communication. But the band that is this wireless band that is used for this for VANET is different. Like we have dedicated band from 5.85 megahertz to 5.925 megahertz. So the communication between these two bands is not possible straight away.
Sir, in India, we are using anywhere this technique, sir. In India, sir.
No, in India till now we are not even incorporated the inter-vehicle communication or even the roadside vehicle communication. But nowadays we are getting the smart vehicles. Like we have the vehicles in which we can fix the suppose the speed. They can also detect the nearby any fuel station that is going to come if these vehicles are even wireless provided with wireless communication. Day by day,
You mean
these vehicles
you
are
mean to
coming,
say
so they will be having such kind of technologies. But full-fledged WAN communication is not in our country till date. We have countries like developed countries like Sweden, other countries they have such kinds of
this is
facilities.
coming soon, sir.
Yeah. So any other questions from any?
No, sir, thank you. Thank
Okay,
you, sir. Nice, sir.
thank you, sir. Thank you. So I hope. Okay, I hope there is no further question from any of the participants. So thank you very much for your patience, listening and hearing. And tomorrow morning we will be back here at 9:30.
Thank you, sir.
9:30. Thank you.